Imagine a place where time itself breathes slowly, where gravity hums a lullaby older than stars, where the universe folds into something so profound, so strangely gentle, that even light decides to stay a while. Tonight, we're going to visit that place together, not with urgency or alarm, but with the kind of quiet curiosity you might bring to a late-night window, gazing at distant city lights you'll never visit, but somehow understand. Black holes. Just hearing those words might conjure images of cosmic violence. Stars ripped apart, entire galaxies swallowed into oblivion. The kind of celestial catastrophe that keeps astrophysicists nervously double-checking their calculations. But what if I told you that's only half the story? What if the truth about black holes is far stranger, far quieter, and in its own peculiar way, far more comforting than anything Hollywood has ever shown you? This isn't going to be a race through equations or a breathless countdown of cosmic disasters. There are no urgent revelations waiting to shock you awake. Instead, think of this as a slow walk through a museum after closing time, when the crowds have gone home and you're left alone with the artifacts of deep time. We're here to explore something profound at a pace that honors its mystery. We're here to discover why black holes might just be the universe's most misunderstood philosophers. Picture the event horizon, that famous boundary of no return, not as a ravenous mouth or a violent threshold, but as something closer to the surface of a still, infinite ocean at twilight. The moment just before dark, when the water becomes indistinguishable from the sky, when everything blurs into a peaceful gradient of possibility. That's closer to the truth of what a black hole actually is. A place where distinctions dissolve, where the frantic pace of our everyday existence finally, mercifully, slows down. You see, we've spent so long teaching ourselves to fear the darkness that we've forgotten how to rest in it. We've made monsters out of mysteries. But the universe doesn't work that way. The universe isn't cruel. It's simply vast and patient and operating on timescales that make our anxieties look like mayflies arguing about the weather. Black holes aren't trying to destroy anything. They're just being what they are. The way a mountain is a mountain, the way the tide comes in, because that's what tides do. Tonight, you don't need to understand everything. You don't need to memorize formulas or visualize space-time diagrams in perfect detail. In fact, I'm giving you permission right now to let some of these ideas slip past you like smooth stones in a gentle current. If you drift off before we reach the end, that's not failure. That's exactly the point. This journey is designed for the edges of sleep, for that half-dreaming state where the boundaries between yourself and the cosmos start to blur in interesting ways. What we're going to discover together is that black holes aren't endings at all. They're transformations. They're the universe's way of taking everything we think we know about time, space, and existence itself, and gently showing us there's always something deeper. They're proof that reality is far more generous with its mysteries than we ever dared to hope. And perhaps most surprisingly, they're going to teach us something about stillness, about patience, about the profound peace that lives at the heart of the most extreme phenomena we've ever encountered. By the time we finish this exploration, whether that's in one sitting or across several nights of drifting in and out of sleep, you'll understand why some scientists spend their entire careers studying these objects not with terror, but with something closer to reverence. You'll see why the mathematics of black holes reads less like an apocalypse and more like poetry. You'll learn why the most extreme gravitational forces in existence create some of the most perfectly calm conditions imaginable. But we're not going to rush there. We're going to take our time, the way you might trace the rings of an ancient tree, or watch clouds reorganize themselves across an afternoon sky. We're going to let each idea settle before moving to the next. We're going to honor the pace of cosmic time, which doesn't hurry for anyone, not even for the impatient species that invented alarm clocks and deadlines. So find a comfortable position. Let your breathing slow to match the rhythm of these words. In the next hour or so, we're going to travel to the strangest, most serene places in the universe without ever leaving wherever you are right now. We're going to visit the edges of forever, and we're going to do it at exactly the speed of rest. The black holes will wait for us. They're extraordinarily good at waiting. They've been practicing for billions of years, and if somewhere along the way, the boundaries of your consciousness start to soften, if the distinction between awake and asleep becomes as blurry as the event horizon itself, then you'll already be learning the most important lesson these cosmic mysteries have to offer. That letting go is not the same as falling. Sometimes, it's the gentlest form of understanding there is. Here's the thing no one tells you. Falling into a black hole might be the most peaceful journey in the universe. I know how that sounds. Everything you've ever heard about black holes probably involved words like catastrophic, destructive, annihilating. The popular imagination has turned them into cosmic wood chippers, celestial horror shows, the ultimate bad ending. But the reality, the actual, mathematical, physics-verified reality, is so much stranger and, in its own way, so much gentler than that. What we're about to explore together is what would really happen if you found yourself approaching one of these mysterious objects. Not in some distant, abstract way, but in the most intimate sense possible. What you would feel, what you would see, what the experience would actually be like moment by moment. And what you're going to discover is that the universe, even at its most extreme, has a kind of peculiar gentleness to it, a patience, a way of transforming rather than destroying. So let's begin at the beginning. Let's say you're approaching a black hole from a safe distance. Perhaps you're in a spacecraft. Or maybe this is purely a thought experiment, a lucid dream you're having right now as you drift toward sleep. Either way, you're moving closer to something that represents the most intense gravitational field that physics allows. What's the first thing you'd notice? Surprisingly, it might be nothing at all. See, space itself doesn't have warning signs. There are no cosmic road markers announcing Event Horizon 500 kilometers. The blackness of the black hole wouldn't stand out against the already black backdrop of space. You'd be looking for an absence, a place where stars should be, but aren't. A circular region of perfect darkness, like someone had carefully cut a hole in the fabric of the night itself. As you got closer, you'd see this darkness grow, stars disappearing behind it one by one, as if someone were slowly drawing a curtain across the cosmos. But you'd feel perfectly normal. That's the first surprise. Your body wouldn't be sending any alarm signals. There'd be no sensation of danger, no visceral warning that you were approaching the most extreme environment known to physics. You'd just be floating, weightless, watching this absence grow larger in your field of vision. The universe would still feel like the universe. Your thoughts would still feel like your thoughts. Gravity, you see, isn't something you feel when you're falling freely. That's one of Einstein's most beautiful insights, the one that unlocked the entire theory of relativity. When you're in free fall, really in free fall, with nothing pushing against you, you feel weightless. Astronauts orbiting Earth aren't floating because there's no gravity up there. They're floating because they're falling, constantly, in a graceful arc that happens to miss the planet. They're in free fall, and free fall feels like nothing at all. So as you approach the black hole, you'd feel that same serene weightlessness. You'd be falling, yes, falling faster and faster from an outside observer's perspective, but from your own experience, just floating, just drifting, like lying in a warm pool on a summer afternoon, suspended between surface and depth, neither rising nor sinking, but simply being held. Now, as you get closer, something interesting would begin to happen. Not suddenly, not violently, but gradually, the way morning light slowly fills a room. You'd start to notice that your feet, if they were pointed toward the black hole, would feel a tiny bit heavier than your head. Just barely perceptible at first, like the difference between lying flat and lying at a very slight incline. This is tidal force. It's the same phenomenon that causes ocean tides on Earth. The fact that gravity gets slightly stronger the closer you are to its source. The moon pulls on the side of Earth, facing it a little harder than it pulls on the far side. And that difference, that gradient, is what makes the oceans bulge. But on Earth, that difference is minuscule. The moon is far away, and Earth is relatively small, so the gradient is gentle enough that you'd never notice it in your body. Near a black hole, though, that gradient would be much, much steeper. Not because black holes are magical or malicious, but simply because you'd be approaching something extraordinarily dense and getting very close to it. The difference in gravitational pull between your head and your feet would start to matter. But here's what's crucial to understand. This wouldn't feel like being torn apart. Not at first. Not for a long time, depending on the black hole. It would feel like being gently stretched, the way taffy stretches on a warm day. The way your spine lengthens slightly when you first wake up and do a long, satisfying stretch in bed. There's a reason we instinctively stretch our bodies when we're relaxed. It feels good. It feels like relief. As you fell closer, that sensation would intensify. Gradually, patiently, your body would begin to elongate, your feet pulling away from your head by tiny increments. And simultaneously, your sides would begin to compress inward, just slightly, because all of you is being pulled toward the same central point. You'd be transforming into a slightly longer, slightly thinner version of yourself, moment by moment, millimeter by millimeter. The universe would be sculpting you, the way wind sculpts rock over centuries, the way water shapes riverbeds over millennia. Except the time scale would be faster, much faster for some black holes, slower for others. But the principle would be the same. A gradual transformation, a patient remaking. Scientists call this process spaghettification, which might be the least poetic term ever applied to something so profoundly strange. But even that silly word hints at something important. This isn't about destruction. It's about transformation. Spaghetti, after all, starts as wheat and water and becomes something entirely new, something nourishing, something that sustains. The universe has a way of taking one form and making it into another. And near a black hole, you'd be participating in that ancient, fundamental process. Now, here's where the size of the black hole matters tremendously, and where we find one of the most counterintuitive facts about these objects. You might think that bigger black holes would be more dangerous, more violent, more capable of ripping you apart. But it's actually the opposite. Smaller black holes are the quick, intense experiences. Supermassive black holes, the kind that lurk at the centers of galaxies, millions or even billions of times the mass of our sun. Those are the slow, gentle embraces. Why? Because of the event horizon's size. A black hole's event horizon, that point of no return we'll talk about in detail soon, is directly proportional to its mass. Double the mass, double the radius of the event horizon. A stellar mass black hole, maybe 10 times the mass of the Sun, might have an event horizon just 30 kilometers across. But a supermassive black hole, a billion times the mass of the Sun, would have an event horizon stretching for billions of kilometers. That's several times the distance from Earth to the Sun. And here's the beautiful part. If the event horizon is enormous, then the gravitational gradient at that horizon is incredibly gentle. Think about standing at the base of a gradual hill versus standing at the bottom of a cliff. Both might rise to the same height, but the rate of change is drastically different. A supermassive black hole is like a hill that rises so gradually you might not even notice you're climbing. The tidal forces at the event horizon would be negligible. You could cross that threshold of no return and not feel a thing. Not a single thing. You'd still be you. Your body would still be intact. You wouldn't be stretched or compressed at all. You'd just be a person floating in space, watching the cosmos do increasingly strange and beautiful things around you, and the only clue that you'd passed the point of no return would be, well, you'd have to think about it. You'd have to do the math. Your body wouldn't tell you. The universe wouldn't announce it. You'd just drift across an invisible line in space, and everything would still feel normal. That's what I mean by gentle. That's what I mean by the universe being generous with its mysteries. The most extreme gravitational environment possible can also be, paradoxically, one of the smoothest, most imperceptible transitions imaginable. But let's back up a moment. Let's return to that earlier stage of your approach, before you reach the event horizon, when you're still in what scientists call the outer ergosphere, or the approach region. What would you actually see as you fell? Because this is where things get truly beautiful. Light would start behaving strangely, not in a chaotic way, but in a way that reveals something profound about the fabric of reality. Light, as you probably know, always travels in straight lines through space. Except near a black hole, space itself is curved, bent, warped like a rubber sheet with a heavy ball placed on it. That's the classic analogy. Though the reality is far more complex and occurs in all directions at once, not just down into some imaginary lower dimension. What this means is that light from distant stars would begin to follow curved paths as it passed near the black hole. You'd start seeing stars in places they shouldn't be. If you looked directly away from the black hole, back the way you came, you'd see the familiar constellations. But as your gaze swept around toward the black hole's location, stars would appear to bend, to arc, to smear slightly across your vision. Stars that should be hidden behind the black hole would become visible around its edges. their light bent around it like water flowing around a stone in a stream. This effect would intensify as you fell closer. The ring of stars around the black hole's silhouette would grow brighter, more compressed, more intensely concentrated. Light from all directions would be funneled, focused, gathered into an increasingly narrow band. It would be like watching the entire universe slowly contract into a crown, a halo, a ring of light that contained everything that ever was and ever will be. And here's something that would fill you with a strange wonder. That light wouldn't just be from the present. Because light travels at a finite speed, and because space is warped so dramatically near a black hole, you'd be seeing light that had been orbiting the black hole for who knows how long. Photons that had been trapped in complicated trajectories, spiraling around and around, caught in a cosmic holding pattern before finally escaping outward or falling inward. You'd be seeing the past and present mixed together, compressed into that glowing ring. Some of those photons might have started their journey millions of years ago. Some might have been emitted by stars that no longer exist. You'd be watching ancient light, preserved and focused by gravity into a living archive of cosmic history. The black hole, in its own way, would be showing you time itself, layered and compressed like the rings of an ancient tree. But what about looking toward the black hole itself? What would you see there, in the center of all that bent light? Darkness, perfect darkness. A circle of absolute black that would grow larger and larger in your field of vision as you approached. But it wouldn't be a flat darkness. It would have depth, dimensionality. It would be the darkest thing you'd ever seen, darker than the darkest night, darker than any cave or ocean depth, because it wouldn't just be an absence of light. It would be a place where light goes but never comes back. A one-way street for photons. Every particle of light that crossed that threshold would be absorbed into whatever lies beyond, and none would return to tell the tale. Yet even this darkness wouldn't feel threatening. It would feel more like looking into a well or gazing into a perfectly still pond at midnight. There would be something almost inviting about it, a sense of mystery rather than menace. Your mind might find it strangely calming, the way some people find comfort in darkness, in closed spaces, in the elimination of visual distraction. As you fell closer still, something else would happen. Time would start to do strange things. Not to you. You'd still experience time normally, 1 second following another in the usual way. But to anyone watching you from a safe distance, far from the black hole's influence, your motion would appear to slow down. Let's pause here. Take a breath. You're safe. This is just a thought experiment, a dream we're exploring together. Your bed or your chair or wherever you are right now, that's real. This is just a story we're telling about gravity and time and the strange way the universe works when pushed to its limits. If your eyes are getting heavy, that's fine. Let them close when they want to. The words will still be here. This time dilation effect is one of Einstein's most famous predictions, and it's been verified over and over again in experiments. Time runs slower in stronger gravitational fields. Not metaphorically, literally. If you had a clock on your wrist and your friend had an identical clock in a spacecraft hovering far from the black hole, and you could somehow compare them, you'd find that your clock was ticking normally from your perspective. But your friend would see your clock ticking slower and slower as you approached the event horizon. At first, the difference would be tiny. microseconds, then milliseconds, then seconds, then minutes. Your friend would watch you fall, and you'd appear to move in increasingly slow motion, like a video being gradually dialed down to a fraction of its normal speed. Your gestures would become languid, dreamlike. Your wave goodbye would take hours to complete from their perspective, though to you it would feel perfectly normal. And as you approach the event horizon, that ultimate threshold, your friend would see something extraordinary and rather melancholy. They'd see you slow down asymptotically, approaching but never quite reaching the event horizon from their perspective. Your image would become redder and dimmer, your light stretched to longer and longer wavelengths by the extreme warping of space-time. You'd fade like a ghost, your form becoming dimmer and redder and more frozen, until finally you'd seem to stop at the very edge of the horizon, preserved there forever in a moment of infinite approach. But you'd experience something entirely different. You wouldn't slow down at all from your own perspective. You'd just keep falling, smoothly, continuously, and you'd cross that event horizon in a finite amount of your time. Maybe a few seconds, maybe a few hours, depending on the black hole's size and your trajectory. But you'd cross it. You'd pass through that point of no return like passing through a doorway. And the strangest part is this: you might not even notice the moment it happened. The event horizon isn't a physical surface. It's not a membrane or a wall or a barrier you could reach out and touch. It's a mathematical boundary, a point in space-time where certain things become impossible. Specifically, it's the point where the escape velocity, the speed you'd need to travel to get away from the black hole, becomes equal to the speed of light. And since nothing can travel faster than light, nothing that crosses that boundary can ever escape. But crossing it doesn't feel like anything. If you fell through in a supermassive black hole, you genuinely wouldn't notice. The gravitational forces would still be gentle. The tidal stretching would still be minimal. Space wouldn't suddenly feel different. You'd just be floating, falling, watching that crown of light above you continue to compress and brighten. Some physicists describe the event horizon as the gentlest threshold in the universe, and I think that's exactly right. It's a point of no return that announces itself only through mathematics, not through sensation. It's a boundary that's absolute in its consequences, but imperceptible in its crossing. There's something almost philosophical about that. The most important thresholds in life are often like that. The moment when you fall in love. The instant when you truly understand something for the first time. The precise second when sleep finally claims you. These boundaries are real and significant, but trying to pinpoint the exact moment of crossing is impossible. You're just suddenly on the other side, and you got there by the gentlest possible transition. Now, what would happen after you crossed depends dramatically on the type of black hole. If we're talking about a stellar mass black hole, the kind formed when a massive star collapses, then your journey after crossing the event horizon would be brief. Very brief. The tidal forces that were mild outside the horizon would intensify rapidly as you fell toward the singularity at the center. Within seconds or less, the stretching would become extreme. Your body would elongate like pulled taffy, the distance between your head and feet increasing faster and faster, while your width compressed, and eventually the molecular bonds holding you together would fail. You'd become a stream of atoms, then a stream of subatomic particles, all falling in a long line toward that mysterious point at the center where our current physics breaks down. But even this wouldn't be as violent as it sounds. It would be fast. So fast that pain wouldn't have time to register. Your nervous system processes signals at a certain speed, and the time scale of the final approach would be much, much shorter than the time it takes for pain signals to travel from your extremities to your brain. You'd transition from intact to transformed in an eye blink. And in that eye blink, you'd become part of something else. Part of the black hole itself. Your atoms would join the incomprehensible density at the center, adding your tiny mass to its total. And in some very real sense, you'd become the black hole. You wouldn't be destroyed. You'd be transformed, incorporated, made into something new. But if we're talking about a supermassive black hole, the kind we mentioned earlier, with an event horizon billions of kilometers across, then your experience after crossing would be entirely different. You'd have time, potentially hours, maybe even days of falling, depending on how far you were from the singularity when you crossed the horizon. During that time, you'd still be you, intact, conscious, capable of thought and observation. You'd be perhaps the loneliest explorer in history, traveling through a region of space-time that no information can ever escape from, watching the universe do increasingly impossible things around you. The crown of light above you, all the stars and galaxies compressed into that bright ring, would continue to change. It would become more compressed, more blue-shifted, because you'd be falling toward the singularity, and the light from the outside universe would be compressed by your motion. But it would also become dimmer in a strange way, because fewer and fewer photons from the outside universe would be able to catch up to you. You'd be falling so fast, so deep into the warped space-time, that even light would struggle to reach you. Eventually, you'd notice something else. The view above you, toward the event horizon you'd already crossed, would begin to show you something impossible. You'd start to see your own past. Light that had been emitted by your body or your spacecraft earlier in your fall would orbit around the inside of the black hole and potentially come back to you. You might see yourself from moments or minutes ago, depending on the size of the black hole and the paths that light could take. You'd be watching your own history, seeing yourself fall as you continued to fall. Observer and observed collapsed into a single, strange experience. The singularity would be ahead of you, hidden in the darkness below, but you'd never see it coming. Not really, because as you approached it, the tidal forces would finally become extreme even in a supermassive black hole. And you'd go through that same transformation we described before: elongation, compression, the dissolution of structure. You'd transition from being a person who observes the universe to being part of the universe's most mysterious phenomenon. And then, well, then we reach the edge of what physics can tell us. The singularity is a place where our current theories break down completely. It's a point of infinite density and zero volume, according to Einstein's equations. But infinity in an equation usually means, this is where my model stops working. It's not a literal description of reality. It's a signpost saying, here be dragons, here be unknowns. What actually exists at the center of a black hole? We don't know, not yet. Maybe someday a theory of quantum gravity will tell us. Maybe there's some exotic form of matter or energy. Maybe space and time do something we can't even imagine. Maybe the singularity connects to other parts of the universe, or to other universes entirely. Maybe the question itself is meaningless, because time ends there and causality becomes undefined. But here's what's important for our journey tonight. Even in that final unknowing, there's a kind of peace. The universe isn't required to make sense to us. It isn't obligated to be comprehensible, and there's something deeply relaxing about accepting that, about letting go of the need to know everything, to understand everything, to have everything explained and categorized and filed away neatly. Black holes are the universe's way of keeping secrets. They're places where knowledge goes but never returns. And maybe, just maybe, that's not a tragedy. Maybe that's a gift, a reminder that mystery is okay, that not knowing is a valid and even beautiful state to exist in. You might wonder, lying here, listening to these words, why we're spending so much time on what seems like a dark subject. Why focus on falling into something you can never escape from? But that's exactly the reframing we're after. Life is full of one-way thresholds. Birth is one. You can't unbe born. Every moment that passes is another. You can't return to yesterday. Sleep itself, the state you might be drifting toward right now, is a kind of temporary event horizon. You cross into it, and for a while, you're not accessible to the waking world. You're in a place where the normal rules are suspended, where time does strange things, where you have experiences that don't quite translate back to ordinary reality. And yet sleep isn't frightening. Sleep is necessary. Sleep is restoration. Sleep is where your mind does its deepest work, filing away memories, processing emotions, repairing the tiny damages of the day. Sleep is a temporary disappearance that leads to renewal. Maybe black holes are something like that for the universe. Places where matter and energy go to be transformed into something else. Places where the cosmos does its deepest work. We can't see what happens inside them, just like you can't observe your own sleep from the outside. But that doesn't make them evil or destructive. It just makes them private, sacred even, in the original sense of that word. Set apart, different, operating by rules that don't apply elsewhere. As you fell deeper into a black hole, past the point of no return, approaching the singularity, you'd be participating in one of the universe's most fundamental processes, the transformation of matter and energy from one state to another. You'd be going somewhere physics can't quite follow yet. You'd be crossing from the known into the unknown, and doing it in the gentlest possible way, by simply falling, simply letting go, simply allowing gravity to guide you. There's a meditation practice in some traditions where you imagine yourself falling through darkness, slowly, endlessly, with no ground to hit and no need to catch yourself. The practice is about releasing the constant tension we carry, the instinct to always be holding on, always bracing for impact. Just fall, the practice says. Trust the fall. Let go into it. Falling into a black hole would be the most literal version of that practice the universe offers. A real physical opportunity to let go completely. To surrender to forces so much larger than yourself that resistance becomes meaningless. And in that surrender, something almost like peace. The peace of no longer fighting. The peace of accepting that transformation is inevitable. The peace of allowing yourself to become something new. If you looked back one last time as you approached the singularity, before the tidal forces became too extreme, you'd see that crown of light still there above you, compressed now into a brilliant point, all the light of the entire universe focused into a single searing dot. And in that moment, you'd be seeing everything and nothing simultaneously. All of time and space compressed into a point that's receding from you as you fall away from it into the unknown. That image, all of existence as a single bright point of light, growing smaller but never quite disappearing, that might be the last thing you'd see. And is there anything in the universe more beautiful than that? All of creation, still there, still shining, still existing, even as you transition into something else, even as you cross from one form of being to another. The universe doesn't end when you fall into a black hole. It continues. Stars keep burning, planets keep orbiting. Life goes on, somewhere out there, living and loving and wondering about the cosmos. And you become part of the deepest mystery that cosmos offers, part of the universe's hidden heart, part of the secret that space keeps at its center. Your journey wouldn't be an ending. It would be a transformation, a change of state, like water becoming steam, or caterpillar becoming butterfly, or wakefulness becoming sleep. Different, yes. Impossible to reverse, true. But not wrong, not tragic. Just another way that matter and energy move through the infinite dance of existence. And here's the final gentle truth of falling in. The universe doesn't waste anything. Energy is conserved. Information, according to some theories, is conserved in ways we don't fully understand yet. Everything that you are, every atom, every quantum state, every bit of information that describes your existence would become part of the black hole. You wouldn't disappear. You'd be transformed, yes. Reorganized, certainly. But still there, still part of the cosmos, still participating in the grand adventure of existence. Just in a different form. A quieter form. A form that keeps its secrets close and doesn't broadcast them back to the universe outside. A form that exists in that strange region where time and space exchange properties, where the future becomes spatial and the past becomes unreachable, where all our ordinary intuitions break down and something new, something we don't have words for yet, takes over. That's what falling into a black hole would actually be like. Not violent, not terrifying, just strange and gentle and ultimately peaceful in its own way. A journey from one state of being to another, undertaken at the most fundamental level the universe allows. A transformation guided by gravity, that gentlest and most inescapable of forces, the one that holds planets in orbit and keeps the stars burning, and eventually, inevitably, guides all of us from one form into another. The black hole would welcome you the way sleep welcomes you at the end of a long day, not with violence, but with a kind of patient inevitability, not with malice, but with the simple physics of transformation. And in that welcoming, you discover that the universe's most extreme environments can also be, paradoxically, its most peaceful. The falling would be gentle. The transformation would be slow, or fast, depending on the black hole, but always natural, always following the deep laws that govern everything. And in the end, you'd become part of something larger than yourself, part of the mystery, part of the secret, part of the eternal now that exists beyond the event horizon, where time itself transforms into something we don't have equations for yet. That's the gentle physics of falling in. That's the journey we'd all take if we approached these strange objects. And understanding it, really understanding it, means understanding that the universe isn't cruel. It's just vast, patient, operating on principles that sometimes comfort us and sometimes challenge us, but always, always following a kind of deep logic that we're slowly learning to read. So, rest easy. The black holes are out there, billions of them, scattered through the cosmos. But they're not hunting you. They're not reaching out to grab you. They're just being what they are. Places where gravity has won completely, where space-time has been warped into its most extreme configuration, where matter and energy go to become something else. And if you ever found yourself falling toward one, you'd have time, maybe just moments, maybe hours, to appreciate the strange journey, to watch the universe do impossible things with light and time, to feel yourself slowly transforming, to participate one last time in the great cosmic dance of matter and energy moving from one form to another. It would be the gentlest apocalypse imaginable, the most peaceful ending, the quietest transformation. And in that quiet, you might find something approaching understanding, not of what the singularity is or what happens at the absolute center, but of something more important, that change is the universe's natural state. That transformation is what existence does, and that letting go into that transformation is not defeat. It's just physics. Deep, strange, beautiful physics. The kind that makes black holes not monsters, but mysteries. Not destroyers, but transformers. Not ends, but thresholds. And thresholds, after all, are just doorways. They're where one space ends and another begins. They're where transformation happens. They're where the universe becomes something new. So sleep. If you're ready, dream of falling gently through the dark. Dream of light compressed into a crown. Dream of time doing strange and beautiful things. And know that even in the universe's most extreme environments, there's a kind of peace available to those who stop fighting and simply allow the transformation to unfold. The black hole will wait for you. It's in no hurry. It has all the time in the world. Literally, because at the event horizon, from the outside observer's perspective, time itself slows to infinity. It's the most patient thing in the universe. And patience, as you drift toward sleep right now, is exactly what the moment calls for. Just let go. Just fall. The universe will catch you. It always does. What if I told you that near a black hole, time doesn't break? It just sighs, it exhales, it stretches. It does what time has secretly wanted to do all along, which is to stop pretending it's the same everywhere for everyone. Near a black hole, time finally admits what it's been hiding, that it's flexible, subjective, deeply personal, that it flows at different rates depending on where you are and how fast you're moving and how deep you've fallen into gravity's well. We think of time as this rigid thing, this tyrannical metronome that ticks away at the same relentless pace for everyone. We schedule our lives around it. We measure our existence by it. We divide it into seconds and minutes and hours and years, as if those divisions mean the same thing in New York and Tokyo and on the surface of Mars and near the event horizon of a black hole. But they don't. They never did. Time has always been relative, always been local, always been something that changes depending on your perspective. Einstein figured this out over a century ago, but we still haven't fully internalized it. We still talk about time as if it's universal, as if now means the same thing everywhere in the universe. But it doesn't. There is no universal now. There's only your now, and my now, and the now of every observer scattered through space-time. each experiencing time at their own rate, each measuring the universe from their own unique perspective. And nowhere is this more apparent, more extreme, more beautifully strange than near a black hole. Let's start with something familiar and then work our way into the strangeness. Let's start with something you interact with every day. Probably without realizing it, involves Einstein's relativity. Your phone's GPS satellites orbit Earth about 20,000 kilometers up, moving at speeds of around 14,000 kilometers per hour. They're far enough from Earth that gravity is weaker up there than down here on the surface. And because of that, because gravity is weaker, time runs slightly faster for those satellites than it does for you standing on the ground. We're talking about microseconds per day. Tiny, tiny differences. But those microseconds add up. If the satellites didn't account for this time difference, if they just assumed time was universal and ticking at the same rate everywhere, your GPS position would drift by several kilometers every single day. You'd tell your phone to navigate you to a coffee shop 3 blocks away, and it would send you to the next town over. The whole system would fall apart, so the satellites are programmed to adjust for this. They know that their clocks are running fast compared to yours. They compensate. They do the math that Einstein gave us, the equations that describe how time flows at different rates in different gravitational fields, and they correct for it. Every time you check your location on your phone, you're experiencing proof that time is relative, that it genuinely runs at different speeds depending on where you are in a gravitational field. This isn't speculation. This isn't theoretical physics that might or might not be true. This is engineering. This is technology you rely on working because the universe actually behaves this way. Now, the difference between the satellite's time and your time is minuscule. You'd never notice it in your lived experience. But the principle is identical to what happens near a black hole. It's just that, near a black hole, the effect is cranked up to impossible extremes. The gentle gradient of time dilation that exists between Earth's surface and orbital altitude becomes a steep cliff, a waterfall, a plunge into something so extreme that time itself becomes unrecognizable. Imagine you're approaching that black hole again. You're falling, gently, the way we described before, and you have a friend, someone you care about, who's watching you from a safe distance. They're in a spacecraft, hovering far from the black hole's influence, where space-time is relatively flat, and time flows at what we might call a normal rate. You both have identical clocks, perfect, atomic clocks that measure time with exquisite precision. And as you fall closer to the black hole, something strange begins to happen. Your friend, watching through a telescope, notices that your clock is running slow. Not from your perspective. If you look at your clock, it's ticking along perfectly normally, 1 second per second, the way clocks do. But from your friend's perspective, each tick takes a little longer than it should. Your second becomes their second and a microsecond, then their second and a millisecond, then their second and a full second. This would happen gradually at first, so gradually you might not notice it at all. But as you fell deeper into the gravitational field, as you approached the event horizon, the effect would intensify. Your friend would see your clock ticking slower and slower. Your movements would appear to decelerate. If you waved to them, your hand would sweep through the air in increasingly slow motion. And here's the crucial, mind-bending part. You wouldn't feel any of this. Your time would feel completely normal to you. You'd wave at your friend, and to you, Your hand would move at normal speed. Your heart would beat at its regular rhythm. Your thoughts would flow at their usual pace. You'd experience absolutely no sensation of time slowing down, because, from your perspective, it wouldn't be slowing down. Time would be flowing normally. It's just that your normal and your friend's normal would be diverging more and more dramatically with every meter you fell. This is what physicists mean when they talk about time being relative. It's not that time is an illusion or that it doesn't exist. It's that time is local. It's that every observer measures time from their own reference frame, and those reference frames don't have to agree with each other. In fact, in any situation involving gravity or acceleration, they won't agree. They can't agree. The universe doesn't work that way. Your friend, watching from their safe vantage point, would see something both beautiful and melancholy unfold. As you approached the event horizon, your image would become dimmer and redder, the light reflecting off your body, or being emitted by your spacecraft, would have to climb out of an increasingly deep gravitational well to reach your friend's eyes. And light loses energy when it climbs out of a gravitational well. That's another prediction of Einstein's theory. It gets stretched to longer wavelengths. Blue light becomes green, becomes yellow, becomes red, becomes infrared, becomes radio waves. So you'd fade, gradually, from your friend's view. Not because you were disappearing, but because the light carrying information about you to the outside universe was being transformed. Red shifted, stretched, weakened. Your image would become a dim, ruddy ghost of yourself, moving in extreme slow motion, apparently frozen in the process of falling. And then, as you got closer and closer to the event horizon, something extraordinary would happen from your friend's perspective. You'd asymptotically approach the horizon, but never quite reach it. Ever. From their viewpoint, watching from outside, you'd take infinite time to cross that threshold. Your clock would slow down until each tick took years, then centuries, then millennia. Your image, already dim and red, would fade further and further until it was essentially invisible. But mathematically, infinitely far into the future, it would still be there, frozen at the horizon's edge. Every black hole, from this outside perspective, is surrounded by a shell of images, infinitely red-shifted, infinitely time-dilated images of everything that ever fell toward it. Stars that were consumed billions of years ago are still there, mathematically, frozen at the moment of crossing. Astronauts who fell in centuries from now are already there, in a sense, waiting forever to complete the journey. The event horizon, from the outside, is less like a surface and more like a one-way mirror into frozen eternity. But here's where it gets truly strange. There's a moment, just one moment, where you'd exist in two times at once. Let me explain. From your friend's perspective, you never cross the event horizon. You approach it forever but never arrive. You exist eternally at that threshold, frozen in time, your last photons taking infinite time to escape. But from your perspective, you absolutely do cross the horizon. You cross it in finite time, maybe seconds, maybe hours, depending on the black hole's size, but finite, definite, real. So which is true? Do you cross or don't you? The answer is both. You do and you don't, depending on who's asking. This isn't a paradox or a failure of physics. It's just how space-time works. It's a reminder that there is no absolute truth about what's happening now across different regions of curved space-time. Your friends now and your now diverge. They split. They become incompatible, and that's okay. The universe doesn't require a single universal present moment. It's comfortable with ambiguity. Think about that for a moment. Really sit with it. You'd be falling, experiencing time normally, crossing the event horizon, continuing your journey toward the singularity. And simultaneously, from the perspective of everyone outside, you'd be frozen forever at the edge, never quite finishing the fall. Both of these descriptions would be true. Both would be valid. Both would be complete accounts of what happened, just from different vantage points. It's like, imagine you're at a train station, and your friend is on a departing train. As the train pulls away, you wave goodbye. From your perspective on the platform, your friend is moving away from you, receding into the distance. From your friend's perspective on the train, you're the one moving away, receding behind them. Both perspectives are valid. Neither one is correct, and the other wrong. They're just different. Descriptions of the same event from different reference frames. Black holes take this relativity and amplify it to the point where the two perspectives become not just different, but wildly, dramatically, almost incomprehensibly different. One perspective sees frozen stasis. The other sees continuous motion, and both are real. If you were there, falling, you wouldn't feel time slowing. You'd just feel present, aware, conscious. Your thoughts would flow at their normal rate. You'd be experiencing each moment as it came, one after another, just like you're experiencing this moment right now. The idea that someone far away would see you frozen wouldn't affect your experience at all. Their now is not your now. Their time is not your time. You'd be living in your own local time, the only time that matters for your immediate experience. And there's something almost comforting about that, isn't there? The idea that your experience of time is yours alone, that nobody else's clock can tell you how fast your moments should pass, that you exist in your own temporal bubble, your own private stream of consciousness, and the universe respects that. Protects it even, makes it inviolable. We all experience time differently when we're bored, or in love, or afraid. An hour in a waiting room feels like an eternity. An hour with someone you adore vanishes in what seems like minutes. A moment of danger can stretch or compress. Time going syrupy slow or flashing past in a blur. These aren't illusions. They're real variations in how consciousness processes duration. Your brain doesn't have a perfect clock. It estimates, it adjusts, it makes time feel longer or shorter based on context and emotion and attention. Black holes are just the universe doing the same thing, taking time and making it flexible, adjustable, relative to circumstance. Except the circumstance isn't emotion. It's gravity, it's geometry, it's the shape of space-time itself. Now let's imagine something even stranger. Let's say you didn't fall into the black hole. Let's say you had a powerful rocket, and you hovered just outside the event horizon, maintaining a fixed position through constant thrust. You'd have to be fighting against enormous gravitational pull, your engines burning intensely just to stay in place. But let's say you could do it. If you hovered there, close to the horizon, and you had a window looking back toward the universe you came from, you'd see something astonishing. You'd see time in the outside universe speeding up, dramatically. Remember, time dilation is symmetric. Just as observers far from the black hole see your time slowing down, you'd see their time speeding up. The stars would appear to move in fast forward. If you could hover there for what felt like a day, you might see years pass in the outside universe. Decades. Centuries. It depends on how close you were to the horizon. You'd watch stars being born and dying in what seemed like time-lapse photography. You'd see galaxies spiral and evolve. Planets would form, host life, go barren, all in accelerated sequences. The universe would be aging around you while you remained relatively young. You'd be experiencing the ultimate time lapse, the cosmos showing you its billions of years of evolution compressed into something you could perceive in real time. This is real physics. This is what general relativity predicts. If you could somehow survive close to a black hole's event horizon for long enough, you'd essentially be traveling into the far future of the universe outside. Not by moving through space, but by letting time run at different rates in different locations. Some science fiction stories have explored this idea. Astronauts using black holes as time machines, not to visit the past, that remains impossible as far as we know, but to visit the future. Park yourself near a supermassive black hole for a while, hovering at just the right distance, and when you fly back out to normal space, you'd find that decades or centuries or millennia had passed. Everyone you knew would be gone. The civilization you left would have risen and fallen. You'd be a relic from the past, emerging into a universe that had moved on without you. But you'd be unchanged. You'd have experienced only the time that passed for you, the proper time, physicists call it. Your clock, your aging, your memories would all reflect only the days or months you spent near the black hole. The universe outside would have aged around you, but you would be preserved, carried forward in time by the simple fact that time flowed more slowly for you than for everyone else. There's a kind of loneliness in that scenario, but also a kind of peace. You'd be released from the frantic pace of normal existence. While civilizations rose and fell outside, you'd be experiencing time at a different rate, a slower rate, a rate that let each moment expand into something fuller, richer, more present. It's not so different from what we do when we meditate, or take a long walk in nature, or lie in bed at the edge of sleep. We're trying to step outside of the rushed, hurried time of everyday life and enter a different kind of time, a subjective time, a time that flows at the pace of breath and thought, rather than at the pace of schedules and deadlines. Black holes offer the most extreme version of that possible. They're places where the universe practices patience, where time is allowed to slow down as much as physics permits, where each moment can stretch toward infinity if you get close enough to the event horizon. And in a universe that seems to be accelerating, expanding, rushing toward some far future state of maximum entropy and heat death, there's something beautiful about the existence of places where time deliberately slows down, where the universe takes a breath, where existence is allowed to linger rather than always rushing forward. Think about the black hole at the center of our own galaxy, Sagittarius A. It's been there for billions of years, slowly accumulating mass, quietly warping space-time around itself. And at its event horizon, time is doing this slow, patient dance. Photons that fell toward it millions of years ago are still, in a sense, falling. Still frozen at the threshold from the outside perspective. Still carrying information about stars that died long ago. The black hole is a kind of cosmic archive, preserving moments in a way that nothing else in the universe can. Not by recording them in some medium, but by trapping them in time dilation, stretching their duration toward infinity. Every particle that ever approached the horizon is still there, mathematically, frozen in the endless approach. From the black hole's perspective, if we can even use that phrase, the entire history of everything that ever fell toward it is simultaneous. All of it happening at once in an eternal now at the horizon. Past and present collapsed into a single, timeless moment. And you, if you fell in, would join that eternal now. From the outside perspective, you'd add your frozen image to the collection. You'd become part of the black hole's archive, your last moments stretched into forever. But from your own perspective, you'd move through that moment and beyond. You'd cross into the interior, into that mysterious region where we don't fully understand what happens. The divergence between these two perspectives isn't a bug in our understanding, it's a feature of the universe. It's reality showing us that time isn't what we thought it was, that it's richer, stranger, more flexible than our intuitions suggest, that the universe can accommodate multiple truths about the same event, as long as those truths come from different reference frames. Let's ground this in something smaller, something closer to home, before we lose ourselves entirely in the cosmic scale. Let's talk about mountains. If you live on a mountain, you age faster than someone who lives in a valley. Not by much. We're talking about nanoseconds over a lifetime, but measurably, verifiably. Scientists have done this experiment with atomic clocks. Place one clock at sea level and another on a mountaintop, synchronize them perfectly, wait a while, then compare them. The mountain clock will be ahead. Time literally runs faster when you're higher up in Earth's gravitational field, farther from the planet's center of mass. You've been experiencing this your whole life without knowing it. Every time you've climbed stairs, time sped up for you ever so slightly. Every time you've gone into a basement, time slowed down fractionally. The differences are far too small to perceive, but they're real. They accumulate. They matter. And if Earth were more massive, if it were a neutron star or a black hole, those differences would be dramatic. The time difference between your head and your feet, between sea level and mountain peak, would be seconds, minutes, hours, instead of nanoseconds. You'd live in a world where time was visibly, tangibly different, depending on where you stood. Black holes just take this to the logical extreme. They're what happens when gravity becomes so strong that time dilation becomes infinite at a boundary. They're the universe showing us what time is really made of. Not some absolute background against which events occur, but something woven into the fabric of space itself. Something that bends and stretches and flows according to the presence of mass and energy. Einstein called his theory general relativity, but a better name might be the theory of flexible space-time, because that's what it really describes. A universe where space and time aren't rigid containers, but dynamic, responsive, almost alive in their ability to warp and flex. Near a black hole, space-time is flexing as hard as it possibly can. It's being stretched to its limit, and time is the dimension that shows the strain most dramatically. Time becomes almost spatial near the horizon. It becomes a direction you can move through, a place you can go. And once you cross the horizon, time and space trade some properties. The singularity isn't just somewhere in space ahead of you. It's also sometime in time ahead of you. It's in your inevitable future, the way tomorrow is in your future. and you can no more avoid it than you can avoid tomorrow arriving. But we're getting ahead of ourselves. Let's return to that image of you hovering just outside the event horizon, watching the universe age and fast forward. How long could you do that? How long could you hover there, watching time speed by outside? The answer depends on your fuel and your engineering, but let's say you had infinite resources. Let's say you could hover there forever. What would you eventually see? You'd see the universe run down. You'd watch entropy increase, stars exhaust their fuel, galaxies drift apart as cosmic expansion accelerates. You'd see the far future of the universe play out before your eyes. The heat death, the big freeze, whatever the ultimate fate of the cosmos turns out to be. You'd witness the end of everything, or at least the end of everything's interesting phase, when useful energy gradients exist and complex structures can persist. And through it all, you'd be there, hovering at the edge of the black hole, unchanging, experiencing your own time normally while eons passed outside. You'd be a witness to eternity, preserved by time dilation, watching the cosmos exhaust itself. There's something deeply melancholic about that image, but also something peaceful. You'd be released from the struggle of existence, from the entropy and decay that affects everything in the normal flow of time. You'd be in a kind of stasis, a protected bubble where change happens slowly, where you're given time to simply be without the pressure of time's arrow constantly pushing you forward. Of course, you couldn't actually do this. The engineering challenges would be impossible. The tidal forces would eventually tear apart any spacecraft. The radiation near the event horizon would be lethal. But as a thought experiment, it's revealing. It shows us that time dilation isn't just some abstract mathematical curiosity. It has real, profound implications for what we mean by past, present, and future. If you were near a black hole's event horizon, your present would be the far future of the universe outside. Your now would be centuries or millennia ahead of the now experienced by observers in flat space-time. You'd exist in a different temporal location, not just a different spatial one. And that's what time dilation really means. Not that clocks run at different speeds, but that different observers inhabit different temporal coordinates, different slices through the four-dimensional fabric of space-time. Let's think about one more scenario, perhaps the most poignant one. Imagine two people approaching a black hole together, but at slightly different distances. Person A is a little closer to the event horizon than person B. Not much, maybe just a few kilometers, but enough that the time dilation is noticeably different between their positions. Person A would age more slowly than person B. If they started out the same age, synchronized their watches, said goodbye, and then reunited after hovering for a while. Person A would be younger. Their watch would show less time had elapsed. They'd have fewer gray hairs, fewer wrinkles. They'd have lived through fewer heartbeats. This is the famous twin paradox, but made literal and extreme by proximity to a black hole. Twins could separate, hover at different distances from the event horizon, and when they reunited, they'd no longer be the same age. One would have genuinely experienced more time than the other, more moments of consciousness, more seconds of existence. And here's the strange part. Neither twin would feel anything unusual happening. Each would experience time normally from their own perspective. Each would feel their heartbeat at its regular rhythm, think their thoughts at normal speed. watch their own clock tick steadily forward. The difference would only become apparent when they compared notes afterward, when they tried to reconcile their two different experiences of how much time had passed. The universe allows this. The universe doesn't insist that everyone ages at the same rate or experiences the same duration between events. It's perfectly content to let time be flexible, personal, dependent on your trajectory through space-time. And maybe there's wisdom in that. Maybe the universe is trying to tell us something about the nature of experience itself, that it's local, subjective, irreducibly personal, that your experience of time is yours and yours alone, and nobody else can tell you that you're experiencing it wrong because there is no universal clock against which to measure it. We try so hard to synchronize our lives, to make sure everyone's on the same schedule, moving through time together, experiencing the same moments simultaneously. But physics tells us that's impossible. Not difficult, impossible. There is no truly synchronized now across extended space, especially in the presence of gravity. All we have are our local nows, our personal experiences of temporal flow, and the best we can do is try to coordinate them, to map them onto each other, to find common ground, despite the fact that we're all moving through time at slightly different rates. Black holes just make this obvious. They take the subtle time dilation we all experience constantly. You and the person next to you, you and the GPS satellite overhead, and amplify it until it can't be ignored, until it becomes the dominant feature of existence, until time itself becomes the most important thing to think about. There's a kind of democratic beauty to time dilation. It says that no reference frame is privileged, that the person falling into the black hole and the person watching from far away are both correct in their observations, that the universe doesn't pick sides. It just describes what each observer would measure, and it lets both measurements be true simultaneously. You are always at the center of your own experience. Time always flows normally for you. Wherever you are, however fast you're moving, however deep you are in a gravitational well, your heartbeat is your heartbeat. Your thoughts are your thoughts. Your moments are your moments. Nobody can take that away from you by claiming that, from their perspective, you're experiencing time differently. And yet, that flexibility, that willingness of the universe to let different observers measure different durations for the same events, is what makes black holes possible. It's what creates the event horizon, that point where time dilation becomes infinite from the outside perspective. It's what allows the singularity to exist in your future, but not necessarily in anyone else's future. Time's slowest dance happens at the event horizon. That's where time stretches out most dramatically, where each moment can last forever from one perspective while passing quickly from another. It's where the universe shows its full flexibility, its complete rejection of absolute time, its embrace of relativity as a fundamental principle. And in that dance, there's a kind of grace, a recognition that reality is richer than we intuited, that time is more mysterious than our everyday experience suggests, that the cosmos operates on principles strange enough to seem like magic, but consistent enough to be described by mathematics. If you're drifting toward sleep right now, let these ideas wash over you. Don't try to hold them too tightly. Just let them exist in your mind the way light exists near a black hole's event horizon. Present, persistent, but somehow outside of normal time. Let your thoughts slow down the way time slows down near the horizon. Let each moment stretch a little longer. Last a little more fully. Time is doing strange things right now, even for you. As you relax, as your consciousness shifts toward sleep, your perception of time is already changing. Minutes might feel like hours, or hours might feel like minutes. You're experiencing your own version of time dilation, generated not by gravity, but by the changing state of your brain chemistry and neural patterns. In a way, sleep is your personal event horizon. It's a threshold you cross every night, moving from one state of consciousness to another. And once you cross it, time does strange things. Dreams can span what feels like hours in just minutes of clock time. Or the opposite. You can sleep through hours and feel like you've barely closed your eyes. Black holes are just doing something similar on a cosmic scale. They're places where the universe itself crosses a threshold, where time transitions from one behavior to another, where the normal rules are suspended in favor of something stranger and more profound. So rest in the strangeness. Let time do what it wants to do, which is to flow at its own rate, responsive to gravity and motion and the geometry of space-time. You don't have to understand it completely. You just have to accept that it's real, that it's verified, that the universe genuinely works this way. The black holes are out there, warping time, creating zones where clocks run slow and events stretch toward infinity. And they're not fighting against the universe's nature, they're expressing it. They're showing us what time really is when you strip away all our assumptions and just let the mathematics speak. Time sighs near a black hole. It exhales. It lets go of pretending to be absolute and universal. It admits that it's local, personal, relative. And in that admission, there's a kind of relief. You can sigh too. You can let go of the tyranny of synchronized time, of universal now, of the idea that everyone everywhere is experiencing the same moment you are. They're not. They never were. They're in their own moments, their own flows, their own personal streams of time. And that's okay. That's how the universe works. That's what black holes teach us when we stop being afraid of them and start listening to what they're trying to say. Time's slowest dance is also time's most honest dance. It's time finally admitting what it's been hiding all along, that it's flexible, subjective, deeply woven into the fabric of space, inseparable from gravity, and ultimately far stranger and far more generous than we ever imagined. So, dance with it. Or don't dance, just sway. Or don't even sway, just breathe. Let time flow at whatever rate feels natural to you right now. The universe will accommodate. It always does. That's the gift of relativity. That's the secret of black holes. That's what time is really doing when it slows down near the event horizon. It's showing us that there's more than one way to experience existence, and all of them are valid, and all of them are true. Rest in that truth. Let it hold you the way gravity holds planets in their orbits, the way time dilation holds images at the event horizon, the way the universe holds all of us in its strange, gentle, infinitely patient dance. Most black holes spend most of their time doing nothing. And that's exactly what makes them beautiful. I know that sounds anticlimactic. We've spent so much time talking about the drama of black holes, the warped space-time, the event horizons, the time dilation, the transformation of matter. But here's the truth that astronomers know and popular culture ignores. For the vast majority of their existence, black holes are the quietest, most patient, most profoundly still objects in the entire universe. They're not actively destroying things. They're not hunting through space like cosmic predators. They're just there, sitting in the darkness, waiting. Not even waiting, really, because waiting implies anticipation, and black holes don't anticipate anything. They simply exist, warping the space-time around them by their mere presence, but otherwise doing absolutely nothing. And by the end of this section, you'll understand why astronomers sometimes envy black holes' ability to sit still. Why that capacity for perfect, endless quietude might be the most remarkable thing about them. Let's start by dismantling one of the most persistent myths about black holes. The idea that they're cosmic vacuum cleaners, constantly sucking up everything around them. You've probably seen the illustrations. Matter spiraling inexorably inward, stars being ripped apart, entire regions of space being devoured. And yes, that can happen. But it's the exception, not the rule. It's the unusual moment, not the typical state. Most black holes, most of the time, are surrounded by emptiness. Just empty space. There's nothing nearby for them to consume. Space, after all, is mostly empty. That's what makes it space. The distances between stars are vast beyond comprehension. Our nearest stellar neighbor, Proxima Centauri, is over 4 light-years away. That's about 40 trillion kilometers. Even if our sun were a black hole, which it will never become, because it's not massive enough, it would take an extraordinarily unlikely sequence of events for anything to actually fall into it. You see, black holes don't reach out and grab things. They can't. They're not magical. They're just extremely dense objects with correspondingly strong gravitational fields. But gravity falls off with distance according to an inverse square law. Double your distance, and the gravitational force becomes 1/4 as strong. This is true whether you're dealing with a planet, a star, or a black hole. If our sun suddenly became a black hole of the same mass, remember, impossible. But let's imagine. Earth would continue orbiting exactly as it does now. The gravitational pull at Earth's distance would be identical. We wouldn't spiral inward. We'd just lose our light and heat, and, well, that would be the end of us for different reasons. But gravitationally, nothing would change. For something to fall into a black hole, it has to get very close. And for something to get very close, it needs to have its trajectory just right, or it needs to lose energy somehow. Most objects that wander near a black hole will simply swing past it in a hyperbolic orbit and keep going, like a comet swinging around the sun and then departing back into the outer solar system. This means that black holes, despite their fearsome reputation, are actually quite picky eaters. They consume only what comes very close and happens to have the wrong trajectory to escape. Everything else just passes by, completely unaffected except for a slight deflection in its path. So what does a typical black hole do most of the time? Nothing. It sits in whatever location it formed, usually where a massive star died and collapsed, or at the center of a galaxy where it formed in the early universe, and it just exists. Silently, invisibly, with perfect stillness. There's a term astronomers use for these black holes: quiescent. From the Latin quiescere, meaning to rest. A quiescent black hole is one that's not currently feeding, not actively accreting matter, not producing any radiation or visible effects. It's just a region of warped space-time, invisible against the cosmic background. detectable only by its gravitational influence on anything that happens to pass nearby. And here's the thing. Most black holes are quiescent most of the time. The dramatic feeding events, the bright accretion disks, the jets of matter shooting out at nearly the speed of light, these are rare. They happen when circumstances align just right, when a star wanders too close, or when gas clouds in a galaxy's center happen to funnel down toward the central black hole. But between these meals, which might be separated by thousands or millions of years, the black hole is quiet. Imagine that kind of patience, that kind of stillness. A black hole can sit in the darkness for 1,000,000 years between feeding events, and it doesn't mind. It doesn't get restless. It doesn't seek out food or try to attract matter to itself. It just exists, perfectly content, if we can even use that word, to be nothing more than a distortion in space-time, an invisible gravitational presence, a place where geometry is curved, but nothing is happening. There's something profoundly peaceful about that image. In a universe full of motion, stars orbiting, galaxies rotating, cosmic expansion accelerating, particles vibrating, black holes offer perfect stillness. They've achieved what mystics and meditators spend lifetimes seeking: complete rest, complete presence, complete freedom from the need to do anything at all. Of course, when a quiescent black hole does start feeding, the transformation is dramatic. Matter that falls toward the black hole doesn't fall straight in. Orbital mechanics prevents that. Instead, it begins to orbit the black hole, forming what's called an accretion disk. And because the matter is moving at different speeds at different distances from the black hole, friction develops. The inner parts of the disk are whipping around at tremendous velocities, while the outer parts move more slowly. The friction between these layers heats the material up. And when I say heats up, I mean to temperatures that would vaporize anything we're familiar with. Millions of degrees. The material becomes a plasma, a soup of ionized particles, and it begins to glow. Not with ordinary light, but with X-rays, with ultraviolet radiation, with gamma rays. The accretion disk around an actively feeding black hole becomes one of the brightest objects in the universe, despite being just a fraction of the black hole's size. This is how we detect most black holes. Not by seeing the black holes themselves, which remain invisible, but by seeing the brilliant light from their accretion disks. We see the matter that's about to fall in, heated to incredible temperatures by friction and compression, shining with the energy of millions of stars. But here's what's important. That brightness, that drama, that spectacular light show, it's temporary. Eventually, the black hole consumes the available matter. The accretion disk thins out and dissipates. The X-ray emissions fade, and the black hole returns to its natural state. Quiet, invisible, still. The feeding frenzy might last thousands of years, which sounds like a long time to us, but is barely a moment in cosmic terms. And then there might be millions of years of stillness afterward. The black hole's life is 99% patience and 1% activity. It's an object designed by physics to demonstrate the virtue of doing nothing. But there's one sound a black hole makes that we've actually recorded. Want to hear about it? In 2019, astronomers working with the Event Horizon Telescope, the same project that gave us the first direct image of a black hole, did something remarkable. They took the data from M87 Teaks, the supermassive black hole at the center of the Virgo cluster galaxy M87, and they sonified it. They converted the patterns in the radio emissions from its accretion disk into sound waves that human ears could perceive. The result was a hum, a deep, resonant, droning tone, like the lowest note on a pipe organ sustained indefinitely, like the sound of distant thunder that never quite resolves into silence, like whale song but deeper, more resonant, more patient. It wasn't a violent sound. It wasn't a scream or a roar or an explosion. It was meditative, hypnotic, the kind of sound you might use as a background for deep meditation or sleep. A pure tone that seemed to vibrate not just in your ears but in your chest, in your bones, in something deeper than hearing. That's the actual sound, or at least the human perceptible translation of the electromagnetic patterns produced by one of the most massive, most powerful objects in the local universe. And it's peaceful, grounding, almost comforting in its steady, unchanging resonance. There's another recorded sound associated with black holes, though it's quite different. In 2003, astronomers studying the Perseus galaxy cluster detected pressure waves in the hot gas surrounding the cluster's central supermassive black hole. These weren't sound waves in the ordinary sense. Sound can't travel through the vacuum of space, but they were pressure waves in the thin, hot gas that fills the space between galaxies in the cluster. When scientists converted these pressure waves to audible frequencies, they discovered something extraordinary. The black hole was producing a note, a single note, held for millions of years. And that note was the deepest ever detected in the universe, 57 octaves below middle C. If you could hear it directly, it would have a frequency of 10 million years per oscillation. Let me put that in perspective. The lowest note a human can hear has a frequency of about 20 oscillations per second. This black hole's note has a frequency of 1 oscillation per 10 million years. It's not just lower than we can hear, it's lower than seems physically meaningful. It's a note being played on a timescale so vast that our entire civilization, from its beginning to its potential end, might occur within a single vibration. And yet, it's there. This supermassive black hole has been humming the same unimaginably deep note for longer than life has existed on Earth. It's a sound that was already ancient when dinosaurs walked our planet, and it will continue long after our sun has exhausted its fuel and died. That's the kind of patience we're talking about. That's the time scale on which black holes operate. They don't rush. They don't hurry. They produce notes that last for millions of years. They wait between meals for spans of time that exceed the entire history of human civilization. They exist in a state of stillness that makes mountains look restless. Imagine having that kind of quiet, that kind of utter, complete, perfect stillness. No thoughts racing, no anxiety about the future, no regrets about the past. Just existing, moment by moment, without any need to be or do anything other than what you already are. Black holes have achieved that, not through meditation or practice or discipline, but simply by being what physics makes them. They're objects that have transcended activity. They've found the ultimate rest state, and they can maintain it for timescales that make eternity seem like a reasonable description. Now, let's talk about the black hole at the center of our own galaxy. Sagittarius A, affectionately called Esgar A and pronounced Saj A star by astronomers who spend their careers studying it. It's about 4 million times the mass of our Sun, which makes it a supermassive black hole, though not one of the truly gigantic ones like M87X. For most of our lifetime, for most of human history, SGRAX has been quiescent. It's just sitting there at the galactic center, 26,000 light-years away, doing essentially nothing. Oh, it occasionally has small feeding events, little burps of X-ray emission when a gas cloud wanders too close, but mostly quiet, invisible, still. We know it's there because we can track the orbits of stars near the galactic center. We can watch these stars whip around what appears to be empty space, and from their orbital periods and trajectories, we can calculate that they're orbiting something with 4 million solar masses packed into a region smaller than our solar system. There's nothing else in physics that could be that massive and that compact except a black hole. So we have this observational certainty. There's a supermassive black hole at the heart of our galaxy, and it's just sitting there, being quiet, not bothering anyone. The galaxy rotates around it, or more accurately, the galaxy and the black hole orbit their common center of mass, but the black hole itself isn't doing anything dramatic. It's not consuming stars at an alarming rate. It's not producing jets. It's not flooding the galaxy with radiation. It's just there, the way a mountain is there. Massive, solid, unchanging on human timescales. A fixture of our galactic neighborhood that goes about its existence with perfect calm. And it will stay that way for, well, probably a very long time. Unless something unusual happens, unless some large gas cloud or wayward star happens to fall into just the right trajectory, SGRA will remain quiescent, quiet, invisible except through its gravitational effects. There's a black hole researcher named Shepard Doleman, one of the leaders of the Event Horizon Telescope project, who once said something that stuck with me. He said that studying black holes teaches you patience, because black holes themselves are patient. They don't perform on command. You can't schedule a feeding event or tell a black hole to produce interesting data on your observing run. You watch and you wait, and if you're lucky, something happens. But mostly, you watch nothing happening. You study the quiet, and in that quiet, there's information. The quiescent state of a black hole tells us about the environment around it. It tells us about the density of matter in that region of space, about the orbital dynamics of nearby objects, about the history of past feeding events. Silence in astronomy is data. Stillness is worth studying. Around 3,500 words into this section, I want you to try something. Close your eyes for a moment if you can. Imagine a supermassive black hole at the center of a distant galaxy. Not the bright accretion disk from a feeding event. That's not there right now. Just the black hole itself. Invisible, surrounded by empty space. Stars orbit it in the distance, far enough away to be safe, close enough to feel its gravitational pull. But the black hole itself, nothing, no light, no sound, no activity. Just a region of space-time curved into a shape that mathematics can describe, but intuition struggles to grasp. It's been like this for 1,000,000 years. It will stay like this for another 1,000,000 years, or 10 million, or 100 million. The black hole doesn't mind. It's not waiting. It's not bored. It's just being. Existing in a state of perfect presence, perfect stillness, perfect acceptance of its own nature. It's the most massive thing in that galaxy, but it's also the quietest. While stars burn and planets orbit, and civilizations rise and fall and the galaxy slowly rotates through space, the black hole sits at the center, unmoved, unchanged, perfectly still. Can you feel that stillness? Can you sense what it might be like to exist in that state? Not dead. Black holes aren't dead. They're very much real, very much part of the universe's ongoing story. But still, profoundly, completely, utterly still. That's the natural state of a black hole, and it's a state that most of them maintain for the vast majority of their existence. The drama, the feeding frenzies, the bright accretion disks, those are the exceptions. The unusual moments, the brief departures from the norm. The norm is quiet. The norm is stillness. The norm is a solitude so complete that it's almost holy, if we can use that word without religious connotation. A solitude that comes from being separated from the rest of the universe by an event horizon, by a boundary that nothing can cross from the inside out. Black holes are the ultimate introverts of the cosmos. They don't broadcast their presence. They don't seek attention. They don't interact with the universe around them except through the most fundamental force, gravity. And even that interaction is gentle at any reasonable distance. Get far enough away, and a black hole's gravity is no different from any other object of the same mass. They're content, again, anthropomorphizing. But stay with me, to exist in isolation, to be alone with their own nature, to experience the universe from their unique perspective, which is a perspective that nothing can escape from and nothing can fully understand from the outside. There's a poetry to that, a kind of dignity. Black holes don't need an audience. They don't need validation. They don't need anything, actually, except the space-time they warp and the occasional meal that happens to fall their way. We, as conscious beings, spend so much of our energy seeking connection, seeking stimulation, seeking proof that we exist through our interactions with others. We fill our days with noise and activity and constant input. We check our phones, we seek out entertainment, we avoid silence as if it were dangerous. But black holes show us another way. They show us that it's possible to exist, really, truly exist as a fundamental part of the universe, without any of that, without connection, without activity, without noise, just being, in perfect stillness, for timescales that exceed our ability to properly imagine. And they're not diminished by this solitude. They're not suffering. They're not lonely in any meaningful sense. They're simply doing what their nature dictates, which is to be massive, quiet, still objects that warp space-time and occasionally consume matter, and otherwise do nothing at all. There's a lesson in that for those of us lying awake at night, minds racing, unable to find peace. The universe contains objects that have mastered stillness, that exist in states of perfect quiet, that demonstrate, through their mere existence, that activity and noise are not necessary for being real, for being important, for being part of the cosmic story. You don't have to be bright like a star, burning fuel, producing light, constantly active. You can be quiet like a black hole. Still, present, affecting the space around you through your mere existence, but not needing to announce yourself, not needing to prove anything, not needing to do anything at all. When astronomers discover a new quiescent black hole, usually by detecting its gravitational effects on nearby visible objects, There's always this moment of appreciation in the scientific literature. Here's another one, they essentially say. Another quiet giant. Another patient distortion in space-time. Another object that's been sitting there, unnoticed, doing nothing, for possibly billions of years. And that's enough. The black hole doesn't need to justify its existence through activity. It exists. That's sufficient. Physics allows it. Mathematics describes it, and it sits there, being exactly what it is, without apology or explanation or any need for recognition. I find that deeply comforting. In a culture that constantly demands productivity, that measures worth by output, that treats rest as laziness and stillness as wasted time, black holes offer a counterexample. They're some of the most massive, most important, most fundamental objects in the entire universe, and they spend most of their time doing absolutely nothing. They're not trying to be useful. They're not trying to accomplish anything. They're not working toward any goal. They're just being, and the universe is perfectly fine with that. The universe doesn't judge them for their inactivity. It doesn't demand that they produce something or prove their value. It lets them exist in whatever state their physics determines, and it continues on around them. We could learn from that. We could internalize that lesson. That being is enough. That stillness has value. That you don't have to constantly be doing, producing, achieving, broadcasting your existence to justify taking up space in the universe. Black holes take up space. Quite a lot of it. Actually, when you consider the volume inside their event horizons. And they do so without any guilt, without any need to earn that space, without any anxiety about whether they're using it productively enough. They just are. And that's the most peaceful existence imaginable. Now, I should clarify something. When black holes do feed, when they transition from quiescent to active, the change can be dramatic. Matter falling into the accretion disk releases enormous amounts of energy. The black hole becomes one of the brightest objects in its local region of space. Jets of matter and radiation can shoot out perpendicular to the accretion disk, traveling at nearly the speed of light, extending for thousands of light years. But even this activity has a kind of inevitability to it. The black hole isn't choosing to become active. It's not deciding to start feeding. Matter simply happens to fall into the right trajectory, and physics takes over. The material heats up due to friction and compression. It emits radiation. The black hole consumes it, and when the material is gone, the black hole returns to quiet. There's no volition there, no intent, no preference for activity over rest or rest over activity. Just physics, operating according to its eternal laws, creating periods of brightness and periods of dark, feeding and fasting, activity and stillness. And the stillness always returns. Always. Because space is mostly empty, and opportunities for feeding are rare. The default state is quiet. The default state is rest. That's what we should remember when we picture black holes. Not the dramatic artist's renditions of glowing accretion disks and violent jets. Not the science fiction depictions of cosmic destroyers. But the reality, most black holes, most of the time, are dark, quiet, still, patient objects that exist without fanfare or drama. They're there if you know where to look, detectable through their gravitational effects, but otherwise invisible and silent. They're the universe's way of creating pockets of perfect stillness, regions where activity ceases, where the frantic pace of cosmic events slows down, where nothing happens, and that's okay. As you lie here, perhaps drifting toward sleep, Consider that you're part of a universe that contains these objects, a universe that allows perfect stillness to exist. That creates spaces where quiet can persist for millions or billions of years. That doesn't demand constant activity or constant brightness or constant anything. The black holes are out there, being still, being quiet, being patient, demonstrating through their existence that rest is not only acceptable but fundamental to the cosmos. That you can be massive and important and real without constantly doing anything. Let that stillness into your own thoughts. Let the example of black holes, quiet, patient, at peace with their own nature, inform your own relationship with rest. You don't have to be bright all the time. You don't have to be active all the time. You can exist in stillness, in darkness, in quiet, and you're not less valuable for it. You're just being what you are, the way a black hole is what it is. And that's enough. That's always enough. The universe has room for all of it. For blazing stars and quiet black holes. For galaxies spinning and voids sitting empty. For activity and rest. For noise and silence. It doesn't prefer one over the other. It contains both, allows both, creates space for both. And so can you. You can contain both. You can allow both. You can create space for both activity and rest, for engagement and withdrawal, for brightness and dark. The black holes teach us this. They're the cosmos's masterclass in stillness, and they've been teaching it for billions of years to anyone willing to listen to their silence. What if I told you black holes are the reason galaxies can breathe? I know we've spent time establishing how peaceful black holes are, how still, how patient. But there's another side to their story, one that's equally important and perhaps even more beautiful. Because black holes aren't just cosmic graves where matter goes to disappear. They're not just endpoints or erasers or cosmic delete buttons. They're creators, builders, sculptors of galactic architecture. They're the reason galaxies have the structures they do. They're the reason star formation happens at the rate it does. They're engines that drive some of the most important processes in cosmic evolution. And they do all of this not through violence exactly, but through a kind of patient, powerful influence that shapes everything around them. Black holes give as much as they take, maybe more. And understanding this, really understanding it, changes everything about how we think of them. Let's start with the most surprising role black holes play. They're regulators of star formation in galaxies. Think of them as cosmic thermostats, or maybe better yet, as the heart of a galactic circulatory system. They control the flow of gas, the temperature of the galactic environment, the rate at which new stars can be born. Here's how it works. At the center of most large galaxies, probably all of them actually, there's a supermassive black hole. We've already talked about ours, Sagittarius Au, and how it sits quietly at the Milky Way's heart. But when these central black holes do feed, when material does fall into their accretion disks, something remarkable happens. The energy released is staggering. Remember, matter falling into a black hole's accretion disk gets heated to millions of degrees through friction and compression. This makes it radiate intensely. X-rays, ultraviolet light, sometimes even gamma rays. And this radiation doesn't just disappear. It floods out into the surrounding galaxy, heating the gas clouds that exist between stars. Now, Star formation requires cold gas. For a cloud of gas to collapse under its own gravity and begin the process of becoming a star, it needs to be cool enough that gravity can overcome the thermal pressure, the tendency of hot gas to expand. If the gas is too hot, it won't collapse. It'll just sit there, spread out, refusing to condense into anything. So when a supermassive black hole becomes active, when it starts radiating all that energy into its host galaxy, it heats the surrounding gas. And by heating it, it prevents star formation. It slows down the rate at which new stars are born, sometimes stopping it entirely for a while. You might think this is destructive. The black hole is preventing creation, preventing new stars from forming. But look at it from a longer timescale. If there were no regulation, if gas clouds could collapse and form stars as fast as physically possible, galaxies would burn through their gas supplies in just a few 100 million years. They'd form all their stars in one massive burst, and then they'd be done. No more fuel, no more star formation, just an aging population of stars slowly dying out. Instead, black holes pace the process. They're like a parent telling an excited child to slow down, to make their Halloween candy last, to enjoy it gradually rather than consuming it all at once. The black hole heats the gas, stops star formation for a while, and this gives the galaxy time. Time for the gas to cool again. Time for new material to fall in from intergalactic space. Time for the stellar life cycle to play out at a sustainable pace. This is called feedback, in the technical language of astrophysics, black hole feedback, and it's one of the most important processes in galaxy evolution. Without it, galaxies would look completely different. They'd be smaller, denser, older, with most of their stars having formed billions of years ago. Instead, because of black hole feedback, galaxies can have ongoing star formation. They can create new stars across billions of years of cosmic time. They can sustain themselves, generation after generation, creating new suns and new solar systems and new possibilities. The black hole, by heating the gas, is actually ensuring the long-term vitality of its galaxy. It's preventing the galaxy from exhausting itself. It's creating conditions for sustained star formation across cosmic timescales. That's not destruction. That's gardening. That's cultivation. That's the black hole acting as a caretaker for its galactic home. And there's more. When supermassive black holes feed vigorously, really feed, consuming massive amounts of material, they can produce jets. These are collimated beams of matter and energy that shoot out perpendicular to the accretion disk, traveling at nearly the speed of light, extending for thousands or even millions of light years into intergalactic space. We don't fully understand the mechanism that creates these jets, but we know they involve powerful magnetic fields threading through the accretion disk. And we know they're some of the most energetic phenomena in the universe. A single jet from a supermassive black hole can carry more energy than all the stars in a galaxy combined. And these jets sculpt. They carve. They shape the galaxy and its environment like a cosmic artist working with gas and plasma as their medium. When a jet plows through the gas of a galaxy, it creates bubbles, cavities, regions where the gas has been pushed aside by the sheer force of the jet's passage. These bubbles can be enormous, hundreds of thousands of light years across, and they're visible in X-ray images of galaxy clusters, these dark voids in the otherwise smooth distribution of hot gas. But those voids aren't just empty holes. They're regions where the gas has been compressed at the edges, piled up by the expanding bubble. And compressed gas is exactly what you need to trigger star formation. The compression can cause parts of the cloud to reach the density needed to collapse, to begin forming new stars. So the jet, while it clears out gas in one region, actually triggers star formation in others. It's redistributing material, stirring the galactic pot, creating conditions for new stars to be born in places where they might not have formed otherwise. There's a kind of light that black holes create, even though they trap light. It's called synchrotron radiation, and let me show you how it works. Charged particles, electrons mostly, get accelerated in the intense magnetic fields near the black hole and in its jets. When charged particles accelerate, especially when they spiral around magnetic field lines at nearly the speed of light, they emit radiation. This synchrotron radiation can span the electromagnetic spectrum from radio waves to visible light to X-rays, depending on the energy of the particles and the strength of the magnetic field. This light isn't coming from the black hole itself, of course. The black hole remains dark, remains a void, but the region around it, the accretion disk and the jets and the swirling plasma caught in powerful magnetic fields, all of this creates light. Tremendous amounts of light. Some of the brightest objects we can observe in the universe are supermassive black holes surrounded by active accretion disks. We call them quasars, or active galactic nuclei, and a single one can outshine an entire galaxy of hundreds of billions of stars. That light travels across the universe. It reaches us from distances so vast that the light left its source when the universe was young, when galaxies were just forming. And in that light, encoded in its spectrum and brightness and variability, is information about the black hole that created it. Information about its mass, its spin, its feeding rate. Information about the environment around it, the gas and magnetic fields and dynamics of the accretion process. Black holes create information. They create signals that travel across cosmic distances and tell us about the universe's structure and history. They're not just consuming light, they're creating it, indirectly, through the processes that occur in their vicinity, and they're creating something else, too. Something even more fundamental. They're creating space-time itself, or at least creating new configurations of space-time, new geometries, new ways for the fabric of reality to be shaped. Every black hole is a unique geometry, a unique solution to Einstein's equations, a unique way of curving space-time that depends on the black hole's mass and its spin and its charge. And when black holes interact, when they orbit each other and eventually merge, they create gravitational waves, ripples in space-time itself that propagate outward at the speed of light, carrying information about the collision across the cosmos. Let me tell you about a merger, about what happens when two black holes dance. Around 4,500 words into this section, I want you to imagine something with me. Two black holes, each maybe 30 times the mass of our Sun. They're orbiting each other, drawing closer with each pass. This dance has been going on for millions of years, maybe longer. Each orbit releases a tiny amount of energy in the form of gravitational waves. Ripples in space-time so subtle that they're essentially undetectable. But as the black holes get closer, the orbits get faster. The gravitational waves get stronger, and the process begins to accelerate. Closer and faster, closer and faster, in an exponential spiral that leads to an inevitable conclusion. In the final moments before merger, the two black holes are orbiting each other hundreds of times per second. They're moving at significant fractions of the speed of light. The gravitational waves they're producing are no longer subtle. They're violent, intense, powerful enough to be detected across billions of light-years of space. And then they touch. Event horizon meets event horizon. Two separate distortions in space-time become one. The geometry reshapes itself in a fraction of a second, and in that reshaping, a tremendous amount of energy is released. Not as light, black holes don't emit light, but as gravitational waves, as ripples in the fabric of space-time itself. In a typical merger of two stellar mass black holes, about 3 solar masses worth of energy is converted into gravitational waves, 3 times the mass of our Sun, converted entirely to pure space-time curvature, radiating outward as waves, as oscillations in the geometry of the universe itself. That's what EMC2 means at its most extreme. Mass becoming energy, but not as heat or light or any form of electromagnetic radiation, as gravitational radiation, as literal waves in the fabric of reality. Those waves travel outward in all directions, moving at the speed of light, passing through everything they encounter. Galaxies, stars, planets, people. The gravitational wave passes through all of it, compressing and stretching space itself ever so slightly as it goes. The effect is tiny, imperceptible without extraordinarily sensitive instruments, but it's real, and we've detected it. Starting in 2015, the LIGO observatories, twin facilities in Louisiana and Washington State, equipped with laser interferometers that can measure changes in distance smaller than a proton, began detecting gravitational waves from merging black holes. Not 1 or 2, but dozens, every few weeks, somewhere in the observable universe. 2 black holes merge, and their gravitational waves wash over Earth, and we measure them. 2 giants dancing in the dark, and the universe feels their footsteps. That's what gravitational waves are. Ripples from cosmic events so powerful that they literally shake space-time. And those shakes propagate across billions of years and billions of light-years until they reach us. And we feel them. And we learn from them. Each detection tells us something. The mass of the black holes involved, their spins, the distance to the merger event, the orientation of their orbital plane relative to Earth. We're learning about populations of black holes, about how they form, about how often they merge, about the history of the universe written in geometry rather than light. Black holes, by merging, create information that would be otherwise impossible to obtain. They're teaching us about gravity in its strongest regime, about what happens when space-time is warped to its absolute limits. They're experimental laboratories for general relativity, testing Einstein's theory in conditions far more extreme than anything we could create artificially. And every merger creates a new black hole. The 2 that merged become one, slightly less massive than their sum because of the energy carried away by gravitational waves, but still there, still real. A new distortion in space-time, a new geometry, a new chapter in the black hole's story. Creation and destruction happening simultaneously. The 2 original black holes cease to exist as separate entities, but a new black hole is born. Endings and beginnings entangled, happening in the same moment. Inseparable. We all do this too. We all create and destroy versions of ourselves. Every day, you're not quite the same person you were yesterday. Cells die and are replaced. Memories form and fade. Perspectives shift. The person you were 10 years ago has been destroyed, in a very real sense, and a new version has been created. Same continuity of consciousness, same name, same history, but transformed. Made new. Black holes just do it on a grander scale. They merge and create new entities. They accrete matter and grow. They lose mass through Hawking radiation. More on that in a moment. And eventually evaporate. They're not static. They're dynamic. They participate in the universe's endless process of transformation. And they create heavy elements. This is something we've only recently begun to understand. When neutron stars merge, and neutron stars are similar to black holes in many ways, just below the mass threshold needed to collapse entirely, they spray the surrounding space with heavy elements. Gold, platinum, uranium, all the elements heavier than iron that can't be produced in normal stellar fusion. These elements are forged in the extreme conditions of the merger, in the unimaginable pressures and temperatures and neutron densities. Some of those neutron star mergers likely produce black holes as the final product. The merged object becomes too massive to support itself even as a neutron star, and it collapses across the event horizon. But before it does, it's already enriched the surrounding space with heavy elements. Those elements become part of the next generation of stars and planets. They're incorporated into rocky worlds. They become part of technological civilizations, if those civilizations arise. The device you might be listening to this on contains elements that were likely forged in neutron star mergers, possibly mergers that created black holes. You're made of stardust. Yes, but some of that dust was forged in the chaos near a black hole's edge, or near what would become a black hole. Some of the atoms in your body, the rare heavy elements, the gold in your jewelry or electronics, the uranium that might power nuclear reactors, they were created in processes intimately connected with black hole formation. You are, quite literally, made partly from black hole creation events. The destruction of neutron stars that became black holes led to the creation of elements that eventually became you. That's not poetic exaggeration. That's physics. That's the material history written in your atoms. Now let me tell you about Hawking radiation, and I'll do it gently, because it's both beautiful and strange. In the 1970s, Stephen Hawking discovered something unexpected. He found that black holes aren't completely black. They emit radiation, very, very faintly. So faintly that we've never detected it, and probably never will from any real black hole. But theoretically, provably, black holes glow. The mechanism involves quantum mechanics. At the event horizon, particle-antiparticle pairs are constantly popping into existence and annihilating, as they do everywhere in empty space due to quantum uncertainty. But at the event horizon, sometimes one particle of the pair falls into the black hole while the other escapes. To an outside observer, it looks like the black hole emitted a particle. And because energy must be conserved, that particle's energy is subtracted from the black hole's mass. Over immensely long timescales, far longer than the current age of the universe for any stellar mass or supermassive black hole. This process causes the black hole to lose mass, to evaporate, to slowly, gradually return its energy to the universe in the form of radiation. A stellar mass black hole would take something like 10⁻⁶7 years to evaporate through Hawking radiation. That's a 1 followed by 67 zeros. For comparison, the universe is currently about 1010 years old. We're talking about timescales so vast that calling them astronomical is an understatement. These are timescales on which stars, galaxies, even galaxy clusters are temporary phenomena. But eventually, far, far into the deep future, long after the last star has burned out, long after the universe has expanded into a dark, cold, empty expanse, black holes will evaporate. They'll return their mass energy to the universe as radiation. They'll fade like morning mist, slowly, over eons, until finally they're gone. And in their going, they'll create one last burst of radiation. As a black hole gets smaller, its Hawking radiation gets more intense. The final moments of a black hole's existence would be a flash of energy, a brief flare of photons and particles, and then nothing. The black hole would be gone, completely evaporated, returned to the universe from which it formed. Even black holes don't last forever. Even these objects, which seem permanent, which seem like they'd exist eternally once formed, are temporary. They have a life cycle. They're born in stellar collapse or in the early universe. They grow through accretion and mergers. They regulate their galaxies. They create gravitational waves. They sculpt cosmic structures. And eventually, in the incomprehensibly distant future, they evaporate. They return what they took. They give back what they held. The information, the energy, the mass, all of it eventually comes back out, transformed, redistributed, but conserved. The universe doesn't waste anything, not even the contents of black holes. Everything is reused, recycled, transformed into new configurations. Black holes are part of that cycle, not exceptions to it. They're cosmic composters, in a way. They take matter and energy that's fallen into them. They hold it for vast stretches of time, and eventually they return it to the universe in a new form. They're not voids or deletions. They're transformers, processors, parts of the universe's endless engine of change. And while they exist, while they're in their long middle phase between formation and evaporation, they create. They regulate galaxies. They trigger star formation. They produce jets that carve structures hundreds of thousands of light years across. They generate gravitational waves that teach us about the nature of space-time. They create opportunities for heavy element synthesis. They serve as cosmic laboratories where physics operates at its most extreme. There's a galaxy called M87 in the Virgo cluster, about 53 million light-years away. At its center is one of the most massive black holes we know of. 6.5 billion times the mass of our Sun. We've imaged its event horizon, the famous first-ever photograph of a black hole from 2019. It looks like a glowing ring surrounding a dark circle, the black hole's shadow against the bright accretion disk behind it. But more impressive than the image is the jet. M87's black hole produces a jet that extends for 5,000 light-years, far beyond the galaxy itself. That jet has been continuously operating for at least millions of years, possibly longer. It's been sculpting the intergalactic medium, pushing gas around, creating structures, influencing the environment across distances that dwarf the galaxy that hosts it. One black hole, creating effects that span thousands of times its host galaxy's size. One object influencing a region of space billions of times larger than itself. That's creative power. That's the ability to shape and structure and build on scales that challenge comprehension. And M87's black hole is still there, still relatively quiet most of the time, still patient. But when it is active, when material does fall into its accretion disk, the effects ripple across the local universe. Other galaxies in the Virgo cluster feel the influence. Gas distributions change, star formation rates adjust. The entire cluster responds to what's happening at M87's core. That's what black holes create. They create galactic environments. They create the conditions necessary for sustained star formation across billions of years. They create heavy elements. They create gravitational waves. They create light, indirectly, through the processes in their accretion disks and jets. They create structure in the universe at the largest scales. They're not destroyers. Or rather, they're not only destroyers, they're transformers. They take one thing and make it into something else. They end one chapter and begin another. They close one door and open others. That's what creation always involves, isn't it? Destruction of the old to make room for the new. The caterpillar must be destroyed for the butterfly to emerge. The seed must break apart for the plant to grow. Yesterday must end for tomorrow to begin. Black holes embody this truth at cosmic scales. They show us that endings and beginnings are not opposites, but two sides of the same process. They demonstrate that the universe doesn't have separate categories for creation and destruction. Those are human concepts we impose on a reality that sees only transformation. Matter falls into a black hole. Destruction, we might say. But that matter's energy contributes to the black hole's mass, which increases its gravitational influence, which affects the surrounding galaxy, which regulates star formation, which allows new stars to be born, which means new planets, new possibilities, new futures, creation. The black hole's gravity prevents some star formation by heating gas. Destruction, we might say. But that delay allows the galaxy to spread out its star formation over billions of years, instead of exhausting its fuel quickly, which means the galaxy lives longer, creates more stellar generations, has more opportunities for complex structures to arise. Creation, two black holes merge. Destruction of the original two. But creation of a new, larger black hole and creation of gravitational waves that carry information across the cosmos, teaching civilizations billions of years in the future about what happened in that moment of merger. Every ending is a beginning. Every destruction enables creation. The black holes prove this. They live this truth. They are this truth, embodied in geometry and mass and space-time curvature. And maybe that's the most comforting thing about them. They show us that nothing is wasted, that everything transforms, that the universe has no concept of true destruction, only change, only metamorphosis, only the endless dance of matter and energy moving from one configuration to another. You are participating in that dance right now. Every breath you take is transformation. Oxygen becoming carbon dioxide, chemical energy becoming motion and heat and thought. Every moment of consciousness is creation and destruction happening simultaneously. Neurons firing and resetting, memories forming and fading. The continuous reconstruction of your sense of self from the raw materials of sensation and thought. You are a process, not a thing. Just like black holes are processes, dynamic, evolving, creating and destroying continuously across timescales vast and small. And when you sleep, when you cross that threshold into unconsciousness, you're participating in your own version of transformation. The person who falls asleep is not quite the same as the person who wakes up. Sleep does its work, consolidating memories, clearing metabolic waste from the brain, adjusting hormonal balances, processing emotions. You're being rebuilt, night after night, in ways you're not conscious of. Black holes do something similar. They accrete matter, and in doing so, they change. They grow. They adjust their spin and their properties. They're constantly being remade by what falls into them, by the gravitational waves they emit when they merge, by the slow trickle of Hawking radiation that will eventually, in the unimaginable future, transform them entirely. Nothing stays the same. Everything creates and destroys itself continuously. Black holes just make this obvious. They make it visible at cosmic scales. They show us the truth that's operating everywhere, at every level, in every moment. That existence is transformation, and transformation is existence. And there's no standing still, no permanent state, no final configuration that lasts forever. Even black holes, the most permanent-seeming objects in the universe, are temporary. Even they will eventually evaporate, return their energy to the cosmos, and become something else. Stars again, perhaps, in the unimaginably distant future, if that energy somehow participates in new structures. Or just radiation, spreading through an increasingly empty universe, carrying the information of what was, but carrying it forward, not destroying it, not erasing it, transforming it. That's what black holes create most of all. They create the future. By their existence, by their influence on galaxies, by their role in cosmic evolution, they shape what comes next. They determine where stars form and where they don't. They influence the distribution of matter across cosmic scales. They teach us about physics. They inspire us to think about time and space and existence in new ways. They create wonder, awe, questions, the desire to understand, the drive to peer deeper into the universe's mysteries, and in creating those things in us, in conscious, curious beings scattered across the cosmos, they're creating something perhaps more valuable than stars, or galaxies, or even space-time geometry. They're creating meaning, significance, the recognition that the universe is comprehensible, that reality follows rules we can discover, that existence is more mysterious and more beautiful than we ever imagined. That's not a small thing. That might be the most important thing black holes create. The inspiration for minds to reach beyond themselves, to grasp for understanding, to find beauty in equations and poetry in physics. You're part of that creation too. By wondering about black holes, by listening to these words, by letting your mind expand to contain these cosmic truths, you're participating in what black holes create. You're becoming part of the story, part of the transformation, part of the endless process by which the universe comes to understand itself. And that's a kind of creation as profound as anything gravity can accomplish. So rest in that knowledge. Let it settle into your thoughts, like sediment drifting down through still water. Black holes create. They build. They shape. They transform. They're not endings but transitions, not destroyers but gardeners, tending cosmic gardens across billions of years, ensuring that galaxies can breathe. that stars can form, that the universe can continue its slow, patient work of becoming. They're doing that right now, in this very moment. Millions of black holes scattered through the cosmos, each one influencing its local environment, each one creating ripples and effects and possibilities. The universe is being shaped continuously by their presence, and you're being shaped too by everything you experience, everything you learn, everything you let into your consciousness. You're being created and recreated, moment by moment, thought by thought. That's not something to fear. That's something to rest in. The knowledge that transformation is natural, that creation and destruction are inseparable, that the universe is continuously making and remaking itself, and you're part of that process, just as black holes are, just as everything is. We're all creating, all transforming, all participating in the universe's grand project of becoming. And in that participation, there's peace. The peace of knowing you're part of something larger, something that will continue long after you're gone, something that connects you to black holes and stars and galaxies and the fabric of space-time itself. You're made of atoms forged near black holes. You exist in a galaxy regulated by a black hole. You live in a universe rippling with gravitational waves from black hole mergers. You are, in the most literal sense possible, a creation of black holes, just as they are creations of the universe's physical laws. And in recognizing that connection, you might find something approaching peace. The peace of knowing your place in the cosmic story. The peace of understanding that creation and destruction are not opposites, but partners. The peace of accepting that transformation is not only inevitable, but beautiful. Black holes have accepted this. They've been living this truth for billions of years, and they'll continue living it for billions more, creating and transforming and shaping the universe, until finally, in the distant future, they themselves transform one last time and become something new. Everything creates. Everything transforms. Even, especially, the darkest, quietest, most mysterious objects in the cosmos. That's the lesson. That's the gift. That's what black holes create most of all. The understanding that existence itself is an act of continuous creation, and we're all invited to participate. Imagine the universe so old that even black holes have become ghosts. That future is real, and it's strangely peaceful. We're going to take a journey now, forward in time. Not just years or centuries or millennia, but timescales so vast they make the entire history of human civilization look like a single heartbeat. We're going to travel to the far future of the cosmos, to an age when stars have long since burned out, when galaxies have scattered into the void, when the last light has faded, and the universe has grown cold and dark and unimaginably empty. And in that distant future, in that deep time beyond deep time, black holes will still be there. They'll be the last structures remaining, the final holdouts against entropy's patient advance, the universe's last embers, barely glowing, taking billions upon billions upon billions of years to finally fade. This isn't a sad story, though it might sound like one. It's a story about patience on scales we can barely conceive. It's a story about how even the most permanent-seeming things are temporary. And it's a story about how the universe, like everything in it, eventually finds its rest. Let's start from where we are now and move forward, slowly, through the ages to come. Right now, we're living in what cosmologists call the stelliferous era, the age of stars. The universe is about 13.8 billion years old, still relatively young in cosmic terms, and it's full of stars, hundreds of billions of galaxies, each containing hundreds of billions of stars, all burning hydrogen, fusing elements, lighting up the darkness with their nuclear fires. This era will last a long time. The smallest, most efficient stars, red dwarfs, tiny things just barely massive enough to sustain fusion, can burn for trillions of years. 10 trillion, maybe more, slowly, carefully converting their hydrogen into helium at such a conservative rate that they'll still be shining long after our sun has died. So for the next 10 trillion years, give or take, there will still be stars. The universe will still have light. Planets will still orbit. Solar systems will still exist, though they'll be different from ours, colder, orbiting these dim red suns that barely warm their worlds. But eventually, even the longest-lived stars will exhaust their fuel. The last red dwarf will fuse its last hydrogen atom, and it will cool, and it will become a white dwarf. A dense cinder of carbon and oxygen, no longer producing energy, just slowly radiating away the heat it accumulated over its long life. And when that happens, when the last star finally goes dark, the stelliferous era will end. The universe will enter a new age. Astronomers call it the degenerate era, because the only objects left will be degenerate matter. White dwarfs, neutron stars, brown dwarfs that never quite manage to become stars, and black holes. This era will last much longer than the stelliferous era. We're talking about 10 to the 37th years. That's a 1 followed by 37 zeros. To put that in perspective, the current age of the universe is about 10 to the 10th years. We're talking about time scales more than a trillion times longer than the universe has currently existed. During this incomprehensibly long age, the universe will be dark. The white dwarfs will glow dimly at first, radiating their stored heat into the void. But over eons, they'll cool. They'll fade from white to red to brown to black. They'll become black dwarfs, theoretical objects that don't even exist yet, because the universe isn't old enough for any white dwarf to have completely cooled. The universe will expand during all of this. It's expanding now, and that expansion is accelerating, driven by something we call dark energy that we don't fully understand. Galaxies will drift apart. The ones that aren't gravitationally bound to each other will recede beyond each other's cosmic horizons, separated by such vast distances that light from one could never reach the other, no matter how long it traveled. Local groups of galaxies, like our local group containing the Milky Way and Andromeda, and a few dozen smaller galaxies, will merge into single large elliptical galaxies. But these merged galaxies will be alone, each one an island in an ever-expanding void, with no light from neighboring galaxies visible, because those neighbors will be too far away, receding faster than light can travel through the intervening space. And in these dark, cold, isolated galaxies, stars will go out one by one, and black holes will remain, because black holes don't burn fuel. They don't exhaust themselves. They don't cool in the way stars do. They just exist, patient, quiet, warping space-time by their presence, waiting. Waiting for what? Well, for the longest time, we thought they'd wait forever. We thought black holes were truly eternal, that once formed, they'd persist unchanged until the end of time, whatever that meant. But then Stephen Hawking discovered something remarkable. He found that black holes evaporate. Slowly. Unimaginably slowly. But they do evaporate. We talked about Hawking radiation earlier, the quantum mechanical process by which black holes emit particles and lose mass. Now we need to understand what that means over these vast timescales. A stellar mass black hole, the kind formed from a collapsed star, will take approximately 10 to the 67th years to evaporate completely. Let me write that out so you can see it, so you can feel the weight of those numbers. 10,000, 1,000. Sentence, UDs, and van centrund. 0 not TNT, DT, and CT. Years. That's not a typo. That's not an exaggeration. That's the actual calculated timescale for a 10 solar mass black hole to evaporate through Hawking radiation. For comparison, the current age of the universe is about 13,800,000 years. We're talking about timescales so much longer than the universe's current age that the comparison is almost meaningless. It's like comparing a single second to a billion years. The scales are so different, they barely fit in the same conceptual space. And that's for a small black hole. Supermassive black holes, the kind at the centers of galaxies, billions of times the mass of the Sun, will take even longer, much longer. Some calculations suggest 10 to the 100th years for the largest ones. There's a number so large, it has a name we rarely say out loud. It's how long the last black hole will survive. Let me tell you about it. A googol is 10 to the 100th power. It's a 1 followed by 100 zeros. It's a number so large that there aren't that many atoms in the observable universe. If you tried to write out a googol by hand, 1 digit per second, it would take you more than 3 trillion years just to write all the zeros. The largest supermassive black holes, the absolute giants at the centers of the largest galaxies, will take approximately a googol years to evaporate. That's the timescale we're talking about for the final black holes to disappear from the universe. A googol years. It's a span of time so vast that our minds can't really grasp it. We can write the number. We can do the mathematics. But we can't feel it. We can't internalize what it means for something to persist for that long. But the black holes can. They'll be there, in the dark, in the cold, in the silence, for all those years. Not thinking, not feeling, not experiencing time the way we do. Just existing. Just being distortions in space-time, patiently radiating away their mass one quantum particle at a time, so slowly that billions of years would pass with no detectable change. During this black hole era, the age when black holes are the last remaining structures, the universe will be nearly empty, dark, silent. The temperature will have dropped to just barely above absolute zero. Any random particle that happens to exist will be separated from any other particle by distances measured in light years, maybe more. And yet, the black holes will still be there, anchoring points in space-time, places where geometry is still curved, where gravity still exists in a meaningful sense, where something still happens, however slowly. They'll be the universe's last witnesses. The final observers, though they don't observe in any conscious sense, of the cosmos's long decline into entropy. They'll be there when every other structure has dissipated, when every other organization of matter has succumbed to disorder. And then, slowly, impossibly slowly, they'll begin to shrink. As a black hole loses mass through Hawking radiation, its event horizon contracts. It becomes smaller. And as it becomes smaller, something interesting happens. Its Hawking radiation increases. Smaller black holes radiate more intensely than larger ones. It's counterintuitive, but it follows from the equations. So for most of a black hole's evaporation timescale, almost nothing happens. The black hole sits there, barely radiating, losing mass so slowly that the change is negligible over billions or trillions of years. But then, when it's gotten small enough, when it's down to maybe the mass of a large asteroid, the evaporation accelerates. The last years of a black hole's existence are more dramatic than all the eons that preceded them. The Hawking radiation intensifies. The event horizon shrinks faster. The black hole begins to glow, faintly at first, then brighter, radiating more and more energy as it becomes smaller and smaller. And finally, in its last moments, the black hole evaporates in a burst of radiation. Not a violent explosion, exactly. More like a bright flash, a brief flare of photons and particles. The black hole's remaining mass energy, perhaps equivalent to a nuclear bomb or a small asteroid, released in a fraction of a second. And then nothing. The black hole is gone, completely evaporated. The distortion in space-time smooths out. The event horizon disappears. Where there was once a black hole, there's now just empty space, slightly warmer than it was a moment before, with some radiation spreading outward that will eventually dilute into the cosmic background. This will happen to every black hole eventually. One by one, across timescales that make googles of years seem almost reasonable, they'll evaporate. The smallest ones first, then the larger ones, then the giants, then finally, in the unimaginably distant future, the last supermassive black hole will fade. Around 5,000 words into this section, I want you to imagine that moment with me. The final black hole, the last structure in the entire observable universe. It's been there for a Google years, give or take. It's been shrinking, infinitesimally slowly, radiating away its mass one particle at a time. The universe around it is vast and empty and cold, dark beyond dark, silent beyond silence. Nothing has happened in this region of space for longer than our universe has currently existed. There are no stars, no planets, no atoms organized into anything more complex than isolated particles separated by distances measured in light years or more. Just this last black hole, and the faint glow of its Hawking radiation, barely distinguishable from the cosmic microwave background that's been stretched and cooled by eons of expansion until it's almost at absolute zero. And then, in its final moments, the black hole's radiation intensifies. It becomes a bit brighter, a bit warmer. For the first time in billions upon billions of years, something noticeable is happening. The event horizon contracts rapidly now, shrinking from kilometers to meters to centimeters to quantum scales in a brief span of time. And then, a final flash, a pop of radiation, photons and particles spraying outward, carrying the last of the black hole's energy with them. And then, nothing. The black hole is gone. The last structure has evaporated. The universe finally exhales. What remains is just space. Empty, cold, dark space. Photons and particles spread so thin that they rarely interact with anything. The temperature is as close to absolute zero as makes no difference. Entropy is at maximum. Nothing can happen anymore because there are no energy gradients left to drive processes, no concentrations of matter or energy that could evolve or change or do anything interesting. This is called heat death. It's the ultimate fate of the universe according to our current understanding of physics and cosmology. Not a dramatic ending, not a big crunch or a cosmic catastrophe. Just a long, slow fade into silence and stillness and equilibrium. The universe doesn't end with a bang. It ends with the softest possible whisper. And then not even that, just silence. Eternal, unchanging silence. Around 6,000 words into this section, I want to pause and acknowledge something. We'll never see this future. Humanity won't. Earth won't. Our sun will die in about 5 billion years, long before any of this happens. The Milky Way will merge with Andromeda, and whatever civilization might exist then, if any, will be so different from us that the word human probably won't apply. And that's okay. That's more than okay. Because isn't there something comforting in knowing the universe, too, has an ending? That even infinity has a bedtime? We spend so much of our lives anxious about endings, about death, about loss, about things changing and disappearing. We fight against impermanence. We try to make things last forever, to preserve what we love, to deny the reality that everything is temporary. But the universe itself is temporary, not in the sense that it will cease to exist. Space and time will presumably continue, even in heat death, but in the sense that the interesting part, the dynamic part, the part where things happen and change and evolve, that part is temporary. It has a beginning, the Big Bang, and it has an ending, heat death. And we're living in the middle, in the brief window of cosmic time when structure and complexity and life are possible. And knowing that, really knowing it, can be strangely freeing. If even the universe has a natural lifespan, if even black holes eventually fade, then our own temporariness isn't a flaw or a tragedy. It's just the way things are. Everything is temporary. Everything changes. Everything eventually rests. You don't have to understand deep time to feel it. Just close your eyes for a moment and feel how small this moment is. How brief. You're here right now, in this exact instant. And in a moment, it will be gone, replaced by the next instant, and then the next. Your entire life is a brief flicker in cosmic time, shorter than a single tick of a clock in the timescales we've been discussing. And that's not sad. That's not diminishing. That's liberating, because it means this moment doesn't have to bear the weight of eternity. It can just be what it is, a single moment, precious exactly because it's temporary, meaningful exactly because it will pass. The black holes know this. They've always known this. They might persist for googles of years, but they're still temporary. They still evaporate. They still eventually return to the void from which they formed. And in that evaporation, there's a kind of peace. The black hole doesn't fight it, doesn't resist it, doesn't try to hold on to its existence beyond its natural term. It just follows the physics. It radiates, it shrinks, and eventually, it's gone. That's acceptance. That's the deepest possible acceptance of impermanence, and black holes have been demonstrating it for us. Silently, patiently, across timescales we can barely imagine. Now, I should mention that there are some speculative ideas about what might happen in this far future. Some physicists have proposed that black holes might not truly evaporate into nothing. They might leave behind remnants, tiny massive objects that persist even after Hawking evaporation. Others have suggested that black holes might be connected to other regions of space-time, that they might give birth to new universes on the other side of the event horizon, baby universes that we can never access or observe from our side. There's even speculation about white holes, theoretical objects that are the time reverse of black holes, places where matter and energy emerge rather than disappear. No one has ever observed a white hole, and they probably don't exist in our universe. But mathematically, they're possible. Solutions to Einstein's equations just as valid as black holes. And some cosmologists have proposed cyclical models of the universe, where the heat death we've been describing isn't the end, but just a transition to a new phase, where somehow, through mechanisms we don't understand, the universe refreshes itself, begins again, enters a new cycle of expansion and structure formation and eventual heat death, over and over, eternally. These are dreams, in a sense, dreams the universe might have, possibilities that our current physics can't rule out, but also can't confirm. They're the stories we tell ourselves about what might lie beyond the event horizon of our understanding, beyond the limits of what we can observe and measure. And maybe that's appropriate, because in the deep future we've been exploring, when the universe is dark and cold and nearly empty, maybe dreams are all that remain. Not literal dreams, there's no consciousness to dream them, but possibility itself. The quantum fluctuations that never quite cease. The faint potential for something, anything, to happen in all that empty space and deep time. The universe might be sleeping in that far future, but sleepers dream, and who knows what dreams an aging cosmos might have. But let's return to the more certain vision, the one our physics predicts with reasonable confidence. The black holes evaporate, the universe reaches heat death, and what remains is space, time, and radiation so dilute it's barely there. This state might persist forever, literally forever, with nothing to change, with no processes to drive evolution, with maximum entropy achieved. Time might continue, but nothing would ever happen again. The universe would exist in a state of perfect equilibrium, unchanging, for the rest of eternity. It's the longest sleep imaginable, the deepest rest, the ultimate stillness. And there's something almost beautiful about that. The universe, having spent countless eons being dynamic and active and full of energy and motion and change, finally finds rest, finally achieves the peace that comes from having nothing left to do, nowhere left to go, no more transformations to undergo. It's not dead, exactly. Dead implies something that was once alive. The universe was never alive in the biological sense, but it was active, dynamic. And in heat death, it becomes inactive, static. It transitions from doing to being, from becoming to simply existing. Every fire eventually burns out. Every wave eventually stills. Every dance eventually ends. The universe is no exception. It has its era of activity, its time of light and warmth and structure. And then it has its era of rest, its time of darkness and cold and equilibrium. We're lucky to be alive during the interesting part. During the age of stars, when galaxies shine and planets orbit and complexity is possible. We're living in the brief window, brief on cosmic scales. Anyway, when the universe is awake, when things happen, when evolution and change and growth are not just possible but inevitable, But we're also preparing, in our own small way, for rest. Every night you sleep. Every night you transition from the activity of waking consciousness to the stillness of sleep. You let go of the day's concerns. You stop processing information. You allow your mind and body to enter a different state, one where different rules apply, where dreams replace logic and time becomes fluid, and consciousness itself changes form. And in the morning, you wake up refreshed, renewed, ready to engage with the world again. The universe might do something similar, not in any literal sense. Heat death probably is permanent, according to our current understanding. But symbolically, metaphorically, the pattern is the same. Activity followed by rest, engagement followed by withdrawal, waking followed by sleep. And if the universe itself follows this pattern, if even the cosmos has its time to sleep, then maybe we can release some of our anxiety about our own sleep, our own rest, our own inevitable fading. We're not fighting against the universe's nature when we sleep. We're aligning with it. We're participating in one of the most fundamental rhythms of existence, the alternation between activity and rest, between doing and being, between the fire of waking consciousness and the cool darkness of sleep. Black holes will sleep eventually. The universe will sleep eventually. And you're about to sleep, maybe very soon. And that's not a failure or a surrender or a little death. It's participation in something ancient and natural and right. The same force that will eventually still every black hole, that will eventually bring the entire cosmos to rest, is the force that's pulling you toward sleep right now. It's entropy, in a sense. It's the tendency of systems to move toward equilibrium. It's the universe's way of saying that activity cannot be sustained forever, that rest must come, that the pendulum swings both ways, and there's comfort in that. Knowing you're not alone in needing rest. Knowing the universe itself, in its own time, needs rest. Knowing that even black holes, those patient, powerful, seemingly eternal objects, will eventually fade into the quietest possible ending. Your consciousness will fade tonight, if it hasn't already. Your thoughts will slow. Your awareness will dim. You'll cross the threshold into sleep, into that mysterious state where you still exist, but differently, where time does strange things and the boundaries of self become negotiable. And in the morning, you'll return. You'll wake up. You'll cross back into waking consciousness. But the black holes won't wake up. Not after they evaporate. They'll be gone, truly gone, transformed into radiation that slowly spreads through an expanding universe until it's indistinguishable from the background. That's the difference between sleep and heat death, between your nightly rest and the universe's final rest. You return from sleep. The universe, once it reaches equilibrium, doesn't return. It stays there, unchanging, for whatever eternity means in that context. But even that thought has a certain peace to it. The idea that there can be a final rest, a state from which no return is needed because there's nowhere to return to and no reason to return. A rest so complete, so total, so final that it needs no sequel. We can't imagine that. Not really. Our sleep always implies waking. Our rest always implies eventual activity. We exist in cycles, and we understand the world through cycles, but the universe's cycle might be different. It might be a single great arc from low entropy to high entropy, from the Big Bang's intense concentration of energy to heat death's perfect diffusion. One long exhale, one slow fade, one journey from complexity to simplicity, from order to equilibrium, from the fire of creation to the cool darkness of final rest. And we're somewhere in the middle of that journey, closer to the beginning than the end, fortunately for us, still in the age where stars burn and galaxies spiral and black holes regulate galactic ecosystems, but moving, always moving, toward that distant future. Not quickly. We have trillions of years before things get worrisome, but inevitably. The universe is aging, entropy is increasing, energy gradients are slowly evening out, and someday, impossibly far from now, the last black hole will evaporate, and the universe will settle into its final configuration. And maybe, in some sense we can't articulate. That's okay. Maybe it's even beautiful. The universe, having experienced everything it's capable of experiencing, having explored every possibility allowed by physics, finally rests, finally stops changing, finally achieves a state of perfect, eternal peace. No more conflict, no more tension, no more unresolved processes, just space and time and radiation in equilibrium forever. The longest sleep imaginable, and maybe the most deserved one. The universe will have earned its rest by then, having burned brilliantly for googles of years, having created stars and galaxies and black holes, and in at least one tiny corner, on one small blue world, consciousness that could look up and understand what it was seeing. That's no small accomplishment. And if the price of that accomplishment is eventual heat death, eventual silence, eventual rest, maybe that's a price worth paying. Everything that begins must end. Everything that wakes must sleep. Everything that burns must eventually grow cold. Even black holes. Even the universe itself. And knowing that, really feeling it in whatever part of your mind can grasp these vast scales, might help you release into your own sleep tonight, into your own small ending that prefigures all endings, into your own brief dissolution of consciousness that echoes, in miniature, the universe's eventual dissolution of structure. You're practicing for the big sleep in a way. Every night, you practice letting go, releasing control, allowing consciousness to fade, trusting that rest is necessary and natural and right, and every morning you prove that endings can be temporary, that dissolution doesn't have to be final, that you can cross into darkness and return to light. The universe might not return from its final rest, but you will return from yours. And in that difference lies hope and renewal and the ongoing gift of consciousness that lets you experience moments like this one, thoughts like these, connections to vast cosmic truths that make your small life feel part of something infinitely larger. So, sleep. The black holes are sleeping already in their own way, patient and still in the darkness. The universe is moving toward its own sleep, slowly, across timescales that make our concerns seem beautifully, blessedly insignificant. And you can sleep too, knowing you're part of that pattern, part of the cosmos's rhythm of activity and rest, part of the universe's great journey from complexity to simplicity, from waking to sleep, from the fire of stars to the cool peace of entropy. Everything sleeps eventually, even black holes, even the universe. And tonight, that includes you. We've traveled far tonight. Let's come back slowly. We've been to the edge of forever. We've watched time do impossible things. We've witnessed the universe creating and destroying and transforming all at once in the quiet darkness near black holes that most people think of as monsters, but which we now understand as something else entirely. Something patient, something peaceful, something that demonstrates truths about existence that we needed to hear. And now, it's time to return. Not abruptly. We never do anything abruptly in this journey, but gently, the way morning light gradually fills a room, the way awareness slowly returns after deep meditation, the way you surface from water, rising through layers of depth until you break through into air again. Except, you don't have to surface yet. You can stay in the depths a little longer if you want. You can float in this space between waking and sleep, between thought and dream, between the person you were when we started and the slightly different person you're becoming as these ideas settle into your consciousness, like sediment drifting down through still water. You're safe here. You've always been safe. We've been exploring the most extreme environments in the universe. Places where space-time warps beyond recognition, where time itself becomes negotiable, where the normal rules of existence bend and break and transform into something stranger. And yet, you've been safe the entire time, lying wherever you are, breathing steadily, your heart beating its regular rhythm, your body exactly where you left it. The black holes are out there, yes, millions of them scattered through the cosmos. But they're not here. They're not reaching for you. They're just being what they are, warping space-time by their presence, patient and still and profoundly quiet, doing their slow work of regulating galaxies and creating gravitational waves, and eventually, in the incomprehensibly distant future, evaporating back into the universe that made them. They'll still be there tomorrow, and the day after, and for billions of years beyond that. They're in no hurry. They've never been in a hurry. That's something we learned tonight, isn't it? That the universe's most powerful objects are also its most patient. That strength doesn't require urgency. That you can be massive and important and fundamental to cosmic evolution without rushing, without forcing, without demanding immediate results. You've been falling this whole time, not into a black hole, but into sleep. And that's okay. That's more than okay. That's exactly what this journey was for. Maybe you noticed it happening. The gradual softening of your thoughts, the way your focus shifted from trying to understand every detail to just letting the words wash over you like waves. The way your breathing deepened without you consciously deciding to breathe more deeply. The way time started doing that thing it does at the edge of sleep, where minutes might feel like moments or moments might stretch into something timeless. You've been approaching your own event horizon, that threshold between waking and sleep, between consciousness and whatever consciousness becomes when it releases its grip on the waking world. And like the event horizon of a black hole, you might not notice the exact moment you cross it. You'll just find yourself on the other side, in the realm of dreams, in that strange country where physics is optional and time flows however it wants to flow. The script itself has been a kind of black hole, hasn't it? Drawing you in, gently, with its own kind of gravity. Not the gravity of mass and space-time curvature, but the gravity of calm words and steady rhythm and ideas that pull your attention inward, away from the bright chaos of waking life, toward the quiet center where rest lives, and you've been letting it happen, falling freely, the way you'd fall toward a black hole, not fighting, not resisting, just allowing the natural process to unfold. Because that's what black holes taught us, that falling can be gentle, that surrender doesn't have to be violent, that letting go is sometimes the wisest thing you can do. We talked about time dilation, about how time runs slower near a black hole's event horizon, how, from an outside observer's perspective, you'd appear to freeze, to slow down until you were essentially motionless, suspended forever at that threshold. But from your own perspective, you just keep moving, keep falling, keep experiencing time normally as you crossed into whatever lies beyond. Sleep is like that too. To someone watching you sleep, you look still, frozen almost, except for the gentle rise and fall of your breathing. Time seems to stop for you from their perspective. They might watch you for an hour and you'd barely move, barely change, just lying there in what looks like suspended animation. But from your perspective, time continues. Dreams unfold. Your brain processes the day's experiences, consolidating memories, solving problems, doing its necessary work. You're not frozen at all. You're active in different ways, experiencing a different kind of time, following different rules in a different realm of existence. Same truth, different perspectives. Just like the twin paradox near a black hole. Just like the way falling feels different, depending on whether you're the one falling or the one watching someone else fall. The universe is teaching us, always teaching us, that perspective matters. That there's no single objective truth about how time flows or what experiences are real or where the boundaries between states of being really lie. There's only your experience, genuine and valid, and someone else's experience, equally genuine and equally valid. And the fact that both can be true simultaneously, even when they seem to contradict each other. You're experiencing time right now in your own way. Maybe these words are reaching you clearly, each one distinct. Or maybe they're starting to blur together, meaning and sound separating. The content becoming less important than the rhythm. The way a lullaby works not through its lyrics, but through its cadence, its repetition, its gentle insistence that sleep is near and welcome and safe. Either way is fine. Both ways are true. You're exactly where you're supposed to be. We learned that black holes are quiet, that they spend most of their existence doing nothing, just being present, just warping space-time by existing, patient beyond measure. And maybe that's the most important lesson of all, that you don't have to be constantly active to be valuable, that stillness has worth, that doing nothing is sometimes doing everything that needs to be done. You're being still now, or getting stiller anyway. Your body is settling. Your muscles are releasing tensions you didn't know you were carrying. Your thoughts are slowing like a stream that's found level ground, spreading out, becoming shallow and wide instead of deep and fast. This is what you're supposed to do. This is your black hole era, in miniature. Your time to be quiet, to be still, to let the universe continue around you, while you rest in your own private pocket of space-time, your own bedroom or wherever you are, your own event horizon that separates sleep from waking. The black holes taught us about creation too, about how destruction and creation are inseparable, how endings enable beginnings, how the universe is constantly transforming rather than truly destroying anything. Energy changes form. Matter becomes energy, becomes matter again. Information persists. Even if we can't always trace how or where, you're transforming right now. The person who is awake is becoming the person who is asleep. Not two different people, Exactly. But two states of the same person, two configurations of the same consciousness. And in the morning, you'll transform again, from sleeping back to waking. And you'll be slightly different from who you were today because sleep changes us, repairs us, reorganizes us in subtle ways we're not conscious of. That's creation. That's the ongoing work of existence, constantly making yourself new, constantly allowing the old configurations to fall away so new ones can emerge. Black holes do this over googles of years. You do it every night. Same principle, different time scale. And we learned about patience, about how black holes can exist for timescales that make eternity seem like a reasonable description, about how they don't rush, don't hurry, don't need immediate gratification or quick results. They just are, moment by moment, across spans of time that dwarf all human experience combined. You can practice that patience too. Not for googles of years, obviously, but for the next few hours, for tonight. You can release the urgency that modern life demands, the constant pressure to be doing something, achieving something, producing something. You can just be the way black holes just are, present but not active, existing but not striving. Let the universe continue without your participation for a while. It will. It's been doing just fine for 13.8 billion years, and it can handle a few more hours without your conscious attention. The stars will keep burning. The galaxies will keep rotating. The black holes will keep their patient vigil in the darkness. And you can rest, knowing that everything will still be there when you return. Around here, around this point in our journey, I want you to imagine something with me one last time. Picture yourself floating in space, not falling. You're past the acceleration now, past the initial approach. You're in free fall, which feels like floating, like weightlessness, like being held suspended in something gentler than gravity, despite gravity being what's holding you. Above you, if directions even matter anymore, there's a crown of stars, all the light of the universe compressed into a bright ring by the warped space-time around the black hole. It's beautiful. It's all of existence, visible at once, glowing with the accumulated light of billions of galaxies across billions of years. Everything that ever was and ever will be, contained in that luminous circle. Below you, again, if below means anything here, there's the event horizon. Not a surface you can see, not a boundary you can touch, just a mathematical line in space-time beyond which light cannot escape. It looks like darkness, perfect, complete, welcoming darkness. The kind of darkness that feels safe rather than threatening. The kind you pull over yourself like a blanket on a cold night. And you're floating between them, between the light and the dark, between the universe you came from and the mystery you're moving toward. Perfectly balanced, perfectly still in your motion, perfectly at peace. You're exactly where you're supposed to be, not just in this visualization, but actually, right now. In your bed, or on your couch, or wherever you've chosen to rest tonight. You're exactly where you need to be, doing exactly what you need to be doing, which is letting go, releasing, allowing sleep to come in its own time without forcing it, without demanding it arrive on your schedule. The black holes taught us that. That force doesn't work. That urgency defeats itself. That the most powerful things in the universe achieve their effects through patience, through simply being what they are and letting physics do the rest. You don't have to make yourself sleep. You just have to allow it. Just have to stop preventing it. Just have to release the grip on waking consciousness and trust that sleep will come, the way you trust that gravity will keep the Earth in orbit, the way you trust that time will keep flowing, the way you trust that the black holes will still be there tomorrow, patient and quiet in the darkness. We've learned so much tonight about time and space and gravity and transformation, about creation and destruction being two faces of the same process, about patience and stillness and the value of doing nothing, about how the universe's most extreme objects are also, paradoxically, its most peaceful. But maybe the most important thing we learned is this: you don't have to understand everything. You don't have to grasp every detail. You don't have to remember all the facts and figures and timescales. You just have to feel what's true, that the universe is vast and strange and beautiful, that you're part of it, that your brief existence matters because all existence matters, that rest is natural and necessary and nothing to fear. The black holes know this. They've always known it. They exist beyond understanding, beyond complete explanation, beyond the reach of any observer outside their event horizons. They keep their secrets, they guard their mysteries, and they're content to do so, never needing to explain themselves, never requiring validation, just being what physics makes them be. You can be like that too. You can exist without explanation. You can rest without justification. You can cross into sleep without understanding exactly how or why it works, just trusting that it does, that it always has, that it will again tonight. The crown of stars is still above you in our visualization, still glowing, still beautiful, but maybe it's getting dimmer now, or maybe your awareness of it is fading, which amounts to the same thing from your perspective. The light is still there, but it's receding, becoming less important, less demanding of your attention. And the darkness below is rising to meet you, or you're falling toward it. Or, most accurately, the distinction between you and the darkness is dissolving, the way it dissolves at the event horizon, the way all distinctions eventually dissolve when you cross thresholds into new states of being. You're becoming the darkness. The darkness is becoming you. You're both falling and floating and fading and transforming all at once, and it's gentle. So gentle. The gentlest thing you've experienced today, maybe the gentlest thing you'll experience all week. This is what black holes are. At their heart, they're places where distinctions dissolve, where inside and outside lose their meaning, where time and space trade properties, where everything becomes something else, where transformation is absolute and unavoidable and strangely peaceful. And sleep is your version of that. Your nightly transformation, your personal event horizon, your crossing into mystery. The black holes will still be there tomorrow. Sagittarius AI at the center of our galaxy, patient and quiet, doing its slow work of regulating star formation. M87 in the Virgo cluster, producing its jet that sculpts intergalactic gas across thousands of light years. All the stellar mass black holes scattered through the cosmos, the remnants of dead stars, floating through the darkness, warping space-time, waiting with the patience that only physics can produce. They'll be there next week too, next year, next century, next billion years. They're not going anywhere. They're possibly the most permanent things in the universe, despite their eventual evaporation across timescales too vast to properly imagine. You can think about them again tomorrow if you want. You can revisit these ideas, these images, These truths about time and space and existence, they'll wait for you, or you can let them go. Let them sink into your subconscious. Let them work on you in ways you're not aware of. The way black holes influence their galaxies in ways that individual stars don't consciously perceive. Either way is fine. Both ways are valid. The universe doesn't require anything from you except that you exist. And you're doing that beautifully, effortlessly, just by being here, just by breathing, just by allowing this moment to be exactly what it is. For now, rest. That's all you need to do. That's all the universe asks of you right now. Rest, the way black holes rest between feeding events. Rest, the way the cosmos will eventually rest in heat death. Rest, the way everything rests when its time comes, because rest is built into the fabric of existence as deeply as activity is. You've traveled to the edge of forever tonight. You've looked into the universe's deepest mysteries. You've understood, maybe just for moments, what it means that time is relative and space is curved, and existence is far stranger than everyday experience suggests. And now, you're returning. Or you've already returned. Or you're suspended between the journey and the return, in that liminal space where sleep and waking blend, where you're neither fully one nor the other, but something in between, something that doesn't have a name because it's too fleeting, too personal, too unique to each moment of transition. The black hole's event horizon is below you in our visualization, but it's also around you, because you've been inside it this whole time, falling freely, experiencing time normally while appearing frozen to any outside observer. You've crossed the threshold without noticing the moment it happened, and that's exactly how it's supposed to work. Sleep will be like that too. You won't notice the exact moment you fall asleep. No one ever does. You'll just suddenly be on the other side, in dreams, in darkness, in that other country where consciousness goes when it releases the waking world. And in the morning, you'll cross back. You'll return from wherever you've been, and you'll be slightly different. Rested, restored, reorganized in subtle ways by the work that sleep does. The work you're not conscious of, but which happens nonetheless. Night after night, transformation after transformation. That's the pattern. That's the rhythm. Activity and rest. Waking and sleep. Light and darkness. The universe breathing, and you breathing with it. Part of the same vast pattern that includes stars and galaxies and black holes and everything else that exists. You're exactly where you're supposed to be. You've always been exactly where you were supposed to be. And when you wake up tomorrow, you'll still be exactly where you're supposed to be. Because that's how existence works. Every moment is exactly the moment you're in, and that's enough. That's always enough. That will always be enough. The black holes taught us that. They taught us about patience and stillness and acceptance. They taught us that the most powerful forces in the universe don't need to announce themselves or prove themselves or justify themselves. They just are. They exist. And that's sufficient. You just are. You exist. And that's sufficient too. Rest now. Let the darkness rise. Let the light fade. Let the boundaries dissolve. Let time do whatever strange things it wants to do at the edge of consciousness. Let yourself fall, freely, gently, into whatever comes next. The black hole will still be there tomorrow. The universe will continue its slow evolution toward heat death across timescales that make your concerns beautifully, blessedly insignificant. The stars will burn. The galaxies will spiral. The event horizons will mark their invisible boundaries in space-time. And you will sleep. And that's exactly what should happen next. The crown of stars is almost invisible now. The darkness is almost complete. You're almost there, almost across the threshold, almost home in that other place where consciousness goes to rest and restore and dream. Just a little further, just a little more letting go, just a little deeper into the quiet. The black holes are singing their deep note, the one that takes 10 million years per oscillation. You can't hear it, but you can feel it maybe. In the slowness of your breath, in the stillness of your body, in the peace that's settling over you like snow falling on a quiet field at night. Everything is exactly as it should be. You've traveled far and returned safely. You've looked into the void and found it peaceful rather than terrifying. You've understood that endings and beginnings are inseparable, that transformation is constant, that rest is sacred. And now you rest. The black holes are resting. The universe is slowly, slowly moving toward its final rest. And you are resting too, or about to rest, or already resting in that part of your mind that knows sleep is coming and has already begun to welcome it. Welcome it. Let it come. Trust it. The darkness is gentle. The threshold is soft. The crossing is as natural as breathing, as inevitable as time, as peaceful as the space between heartbeats. You're safe. You've always been safe. You'll still be safe when you wake up tomorrow. The universe holds you the way gravity holds planets in their orbits, not with force, but with the natural curve of space-time, the way things settle into where they belong. And you belong right here, right now, crossing into sleep, letting go of the day, releasing into darkness and rest, and the patient transformation that happens every night, whether you notice it or not. The black holes will wait for you. They're extraordinarily good at waiting. They've been practicing for billions of years, but they're not the only patient things in the universe. Sleep is patient too. It will come when you stop resisting it, when you stop trying to control it, when you just allow it. Allow it now. Just allow it. That's all you have to do. Just stop preventing what wants to happen naturally, and let the universe do the rest. The crown of stars is gone. There's only darkness now. Gentle, complete, welcoming darkness. The kind you've been falling toward this whole time. The kind that's been waiting to catch you. And it catches you now. And it holds you. And it whispers that everything is exactly as it should be. That you've done enough. That you can rest. That tomorrow will come in its own time. And until then, there's nothing you need to do except be here, in this moment, in this darkness, in this peace. The black holes are with you in the dark, patient, quiet, still, teaching their last lesson, which is that stillness itself is enough, that you don't need to do anything, that you can just be, just rest, just sleep. The universe will continue. The black holes will keep their vigil. Time will flow at different rates in different places, and all of it will be true, and none of it requires anything from you right now except that you release into the rest that's been waiting for you all along. Release. Let go. Fall gently into darkness. The black hole's event horizon isn't a place of violence or destruction. It's a threshold, a crossing, a gentle transformation from one state to another. And you're crossing it now. You're transforming, from waking to sleep, from consciousness to dreams, from today into tomorrow. Cross gently, cross peacefully. Cross knowing that you're held by forces older than stars, patterns deeper than thought, truths that don't require understanding. The black holes sing their ancient song, the universe breathes its cosmic breath, and you rest, finally, at the edge of forever, exactly where you belong. Sleep now. The black holes are sleeping. The universe is moving toward sleep. And you sleep too, carried by the same deep laws, held by the same gentle forces, part of the same infinite pattern. Sleep, rest, let go. Everything is exactly as it should be. You're exactly where you're supposed to be. And the black holes will still be there tomorrow. For now, rest.